everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello everyone and welcome to another WeAreDevelopers live session. I'm Benedict and I'm so glad that you made it. So today is all about the cloud. Well, what is cloud computing exactly? Simply put, cloud computing is the delivery of computing services over the internet or the cloud to offer faster innovation and flexible resources. But before we start, I have some great news for you all. This year, our World Congress is back as an in-person event in June in Berlin. So right after the session, don't forget to go to worldcongress.dev to get further information and to save your spot. Also, during the session, please feel free to interact with each other in the chat to your right. And don't forget to submit some questions as we will have a short Q&A after each talk. But when interacting with each other, please keep in mind that we have a code of conduct. Be nice to each other. Here is a short video about it. So, right back to cloud. We have 4 amazing speakers announced today, and the first one is Thomas Schütz. He is principal engineer at Dynatrace. He has been designing, building, and operating IT infrastructures for 2 decades, and now he focuses on cloud-native app application delivery mechanisms. Please welcome everybody, Thomas Schütz.
Hello, Benedict.
Hello, Thomas. Wonderful to have you. How are you today?
Yes, very fine, thanks. Very excited to be here, the first speaker today.
No need to be excited, just enjoy it. Do you mind asking me where you're from joining us today?
So I'm sitting near Vienna, so also in Austria.
All right, so we are neighbors. So, and furthermore, do you mind telling me and the audience what you're gonna learn from you today?
Yes, so today I worked a lot with GitOps and implementation of GitOps in Captain in the last few months. And I wanted to share some insights and some principles and other things about GitOps with the audience. And yes, this is what you hear today. So my experience from the last few months with GitOps.
Thomas, that sounds very interesting. And without further ado, I would say the stage is yours.
Okay, thank you. So thanks for having me here. As Benedict says, my name is Thomas Schütz. I'm a principal engineer at Dynatrace, tech lead at the CNCF Tech App Delivery, and also a maintainer of the Captain project. And as such, I implemented a lot of GitOps stuff in the last few months. To be honest, a prototype at the moment, but I learned a lot of things which I want to share with you. So what you will hear today. So at first, why do we need GitOps? So some of us might think, yes, we are. Some of you might be sysadmins. We have our tools. Everything is okay for us. And why do we need another thing? Another thing I want to deal with is I want to give you a short overview what GitOps is and how GitOps could be implemented as an example in our Captain project. And last but not least, we'll drive this home and show what we learned today. So at first, when we start to learn Kubernetes, we learn a lot of commands, so such as kubectl create namespace, kubectl run, and so on. And these are all imperative commands. And at some point in time, you will find this pattern in many operations-based situations. And yes, such as in another example, when we get a new server, one of the first thing we might do is an apt-get update, apt-get install. We might change something in our configuration, and afterwards we will restart the process to get this running. So yes, what's wrong with this approach? So at first, when we deal with imperative commands, we need to execute all of the steps we have in the correct order. So, for instance, when you are familiar with Kubernetes, an expose of a service might not work before you create the pod. Furthermore, we have to remember a lot of commands, and we have to know a lot of commands when we are doing operations tasks and sysadmin tasks. Furthermore, our scripting is might be very hard. So when something breaks, we have to deal with it. And we might have some kind of dependencies in our script. So when one command is failed, then we cannot do another thing, and so on. Furthermore, such imperative commands might be very hard to read, and you might have a lot of duplication in further consequence. And when you are dealing with a lot of commands, it might be that your script gets a bit outdated at some point in time, and you have to deal with CLI changes, with other changes in the configuration, and so on. So yes, it might also be that some things you need might not be available in the CLI. So it might be that you have some configuration on API objects, especially in Kubernetes, which you cannot create via the CLI. And last but not least, we as developers, we want to deliver our code, we want to do our configuration, but we do not want to learn commands and not learn special tools. So we need another thing. And at this point, we come to declarative configuration. So at first, we need a configuration mechanism which helps us describing the state we want to get our infrastructure configuration or whatever in. So we might want to tell the system that we want to have an application in a version 001 deployed, not yes, deploy this. Furthermore, only the one who creates the logic behind our configuration needs to know how this works and how to get to the target state. So it doesn't. So the developer itself or the operations guy itself does not need how to get to the target state. He only has to specify the target state. Furthermore, declarative configuration is readable in a very simple way. So we have our YAML file, and we can see our JSON file or whatever, and we can see what we want to see in the end, and therefore it's readable, very nice. And if we combine this with Git, everything is versioned. It might survive changes in the code, so APIs should be versioned, and therefore the objects should not change unintentionally. And yes, further, yes. So how does this look like? So when we take a look on a Kubernetes object, we see that we don't have many imperative things here. So we define that we want to create a pod which has this and this labels, which is in this namespace and uses exactly this container. And yes, when we want to change something, we simply have to change the configuration and also apply this in the end, which makes our lives very easy. And there are controllers behind it which know how to get to the target state. So yes, everything looks fine now after we have a declarative configuration, but we still have to need to apply the configuration. So when we deal with Kubernetes objects, we might do a kubectl apply -f for the configuration file. And yes, if the configuration is only on our machine, then the configuration can drift between developer machines. So let's say I have a configuration file and I send this to another developer. And it might be that I apply the configuration, a newer configuration than the other developer has. And when the other developer applies the old configuration, then it will get reverted. And this is a thing we don't want to achieve. And what's interesting from a security perspective, when we deal with such commands from our machine, then we need Kubernetes API access. And yes, for me, when I'm dealing with deployments and with infrastructure configurations and so on, when I do this manually and from my machine, it could happen that I apply the wrong things in the wrong stage or on the wrong cluster and so on. And therefore, our systems might break. And this is also from a systems administrator's perspective, things we don't want. And last but not least, a big point might be that when I do some configuration changes on my machine and I apply them immediately, this code might not be tested. So there are no mechanisms in place which does some static analysis or dynamic analysis and so on. And yes, also some things we don't want to achieve. So we heard about all of the drawbacks we have here, and we come to the decision, yes, we need more robust. We need to do something more robust. So for me as an old ops guy, I have some assumptions about the way I want to administer my configuration and I want to apply my configuration. So at first, if I automate everything, I can ensure that my configuration and infrastructure is at least a bit tested. And as I do this automatically, I am sure that I apply the correct configuration on the right system. So as long as my automation code is correct, there is no way that I could apply the configuration on the wrong stage. Furthermore, by code reviews as pull requests, merge requests, and so on, I can ensure that at least one of my coworkers is aware of what I did. So when I wrote something and I made some mistakes, which can happen, then at least another one took a look on it and might see that I did something which might break systems. Furthermore, my code is reviewed, so I could make automatic approvals. I could or automatic checks. I can make approvals and so on. Therefore, the quality of my code might be better. And last but not least, and this is the way how we come to GitOps. By using Git, I can ensure that I got a single source of truth for my code. So as I said before, I don't have to put to send the configurations around between the developers. I know that in the Git repository there is my source of truth, and furthermore my code is versioned, and this is very important for me. So I know what. So when I create a new version of something, I know what has changed and when it has changed. So, as I said, we are coming to GitOps, and at first, let's take a look on what GitOps is. And the GitOps working group of the CNCF says GitOps is a set of principles for operating and managing software systems. And these principles are derived from modern software operations, but are also rooted in pre-existing and widely adopted best practices. Long story short, this means that we are using also from an ops perspective or from a systems administration perspective, processes and workflows we are used to from software development. So we don't try to spawn up a shell and configure something. We want to declare our configuration in a declarative language in a repository. We also have some kind of a CI pipeline which checks all of this, which might test the infrastructure code or the application code, and furthermore puts his mark on it below it and says that everything is okay. Therefore, we have two prerequisites. So at first, infrastructure and configuration is declaratively managed. Yes, so if we do our configuration via SSH and shell commands, then it might get hard to get to such an approach, even if it would also be possible. Furthermore, yes, our configuration should be managed in Git, and we should not have it lying on a file server or sending it around via Slack or via email. And therefore, yes, these are the prerequisites we need for that. So there are 4 prerequisites for principles according to the GitOps working group. And at first, as I told you before, our GitOps managed system has to have its desired state expressed declaratively. So yes, I think we talked enough about this. A second thing is our configuration should be pulled automatically. So we should not have to apply something on the GitOps-based system. There should be some kind of a controller which pulls the configuration from a Git repository and uses this as a desired state for the system, which for the state which it would like to get to. At third, the desired state is stored in a way that enforces immutability. So with that we can also always get back to the last version, and we can also say, yes, exactly this state was the thing I deployed at this time, or I used at this time. Last but not least, this all should get continuously reconciled. So as we know from Kubernetes operators and so on, there are mechanisms which can ensure that our system always tries to get to the desired state as we got it in Git. And in our case, so with GitOps, it's always an attempt to apply to the desired state. So what we have in our Git repository might always be an intent. So it says, yes, I want to get the version 1.20 of an application deployed, but there might be things which could avoid this. So then it will never get to this state, but nevertheless, we should know about this. So just as an illustration for such a controller thing, and this is taken from the CNCF operator white paper, and it's describing a bit of the way how such GitOps approaches work. At first, we have a declarative requested state somewhere, and we have the current state on the other hand. Everything is stored somewhere, so the declarative requested state might be stored in a Git repository. The current state might be stored in some state files or wherever. I'll come to that later. And we might have some piece of code, such operational knowledge code, which watches the declarative requested state, might compare this with the current state, and applies this to managed resources, such as Kubernetes deployments and other objects. And after it changed everything, then it will report back the current state to the current status. And this is running in a continuous loop. So yes, this does not necessarily have to be in Kubernetes. We can find this pattern also in other ways or on other places. So when we think of Terraform, which is by default not continuously reconciled, to be honest, but it uses especially the same pattern. We have a declarative requested state, so we have our Terraform configurations, we declare what we want to achieve, and describe our intended target state. Furthermore, we have a current status in our state file, and we have the managed resources. So when we are working in AWS, for instance, we have our instances, we have our load balancers, and so on. And after everything is the operational knowledge code knows how to get to this target state. And after it has applied everything, it reports everything back to the state file or the state repository. So yes, we don't necessarily have to find such patterns in the Kubernetes world. This could also be other things. So how could such a simple GitOps approach look like? At first, a developer wants to develop his code somewhere, and most of the time, or almost every time, at the end of a CI pipeline is the storage of some artifacts, such as container images, such as Helm charts, and so on. And at some point in time, we might think that it is a good idea to bring, especially this exactly the things we want to develop to a system. So this could be at the very left of the process. And therefore, we have to change a second repository. So we might have a Git state repository, which reflects the state of the configuration we want to have on our system. So one thing we might have at the end of our CI pipeline is that we change the configuration of the declarative configuration of our systems. And afterwards, the process goes further. A second thing which might be possible is that this configuration change is not triggered by the CI pipeline. It can also be managed in a more controller-based way. So we might also have a controller which watches on the container registry, looks if there are new container images there, and if something changed, then the controller might change the Git repository. And this is a thing we know from Flux. So there is an image update automation controller there. This also works pretty fine. So now we are in a Git repository at some way, and what we find here is the intent the intended state expressed in a declarative configuration. And we might have some kind of controller operator, or however we call this. And this is kind of piece of code which fetches from a Git repository, translates this into tasks and stores this somewhere. So when we say we want to deploy our version 1.0 somewhere, this piece of code knows, yes, my old version was 1.0.0.1, and how it gets to 0.1.0. Yes. and watches and applies this on managed objects. And the managed objects are the things we create or update via the GitOps managed declarative configuration, such as deployment services, ingress controls, and whatever we know in Kubernetes, or other custom resources we might get in Kubernetes. Furthermore, this logic also reconciles the managed object, so it watches the managed objects, and if something something is changed manually or however, the controller might try to get the managed objects to the new state. And finally, everything of this gets stored somewhere. So when we are staying in our Kubernetes world, we might store this in a custom resource in the status section and so on. Okay, so yes, this was pretty theoretically, and yes, how might this look like in the real world? And I talked a lot about Captain in the beginning. What is Captain? So Captain itself is a distributed control plane for your application lifecycle. So you can use Captain to manage your whole deployment lifecycles, from configuring your monitoring system to deploy something, to test something, do to traffic shifting if you have mechanisms for it, and this also for staging for getting to the next stages. Captain itself is a CNCF sandbox project. It's currently in the incubation process. Furthermore, it has a large ecosystem. So for deployment, you can use Helm and Argo rollouts. You can use kubectl commands and whatever you want to use. You can use Litmus chaos for chaos testing. You have the possibility to use JMeter locust and so on for load testing. And you can write whatever custom integration you want via the job executor. I played around a bit with crossplane with K6 and also for kubectl. Currently, the main use cases for that is continuous delivery. So getting as far as possible from an artifact to a full-fledged deployment. You can use it for quality gates, so evaluate if the deployed applications meet your requirements or your quality standards, and also for remediation purposes. So when you find out that your system doesn't behave as it should like, then Captain should know how to get back. Captain is really based on service level objectives and service level indicators, and currently we have 3 providers for SLIs. The first one is Prometheus, the second one is Dynatrace, and the last and newest one is Datadog. And they can be used to evaluate everything in there. So yes, how did Captain work until today? Captain was also very configurable in a very imperative way. So at first we had to create a project, we had to create a service in the correct order. Furthermore, we had to create some, we had to add some resources. We had need to configure it for a stage and so on. And at first we said, yes, Captain, take everything what we have and deliver that. And yes, after some time we asked ourselves, so we could make this a bit easier. So why should we use GitOps in Captain at first? We could template projects. So we could have some blueprints for our projects and services and stages and whatever Captain has, and could create templates which can always be reused. Furthermore, by using such templates, the onboarding of new projects and new services might be a bit easier. So we don't have to know everything about Captain and all of its commands. We only have to know how the configuration should look like. Furthermore, this whole approach makes the backup of everything easier. So when we have all our configuration in a declarative way, We can easily recreate this. Yes, we might have some databases which could not be recovered this way, but especially for the configuration, this is okay. Furthermore, the configuration is easier, and yes, GitOps and so on is the way we work as developers, SREs and DevOps. So we have everything in Git, we check in everything in Git. Why do we have to learn Captain afterwards? Especially for Captain, one of the main benefits when we use this approach was that we get our whole application lifecycle as code. So the monitoring from monitoring configuration to the deployment configuration to the test configuration and the remediation actions. So we have everything in one Git repository, and Captain knows how this works. So what did we do? First things first, the whole GitOps approach is currently work in progress. So it's in continuous development. Nevertheless, we use it in our own teams. Furthermore, we created custom resource definitions for Kubernetes in for almost every Captain configuration object. So, such as Captain projects, Captain stages, which is currently work in progress, such as sequence templates, services, and so on. The API will tell Captain what we do. So we did not rewrite Captain completely. We only added one component which knows about the custom resources for Captain and is able to translate this in the Captain speech, so in the API. Last but not least, we also built an operator which fetches this configuration from a Git repository and applies them in the Kubernetes cluster. So, yes, I think I talked enough. Let's get to a bit of a demonstration. At first, yes, I have a shell here. And for my to get everything started, I need some kind of configuration which tells my Captain configuration, which tells my Captain operators where to find its Git repository. And let's take a short look on this. I tell the Captain operators that there is a Git repository which is called CircleCI demo with the username and an RSA encrypted password here. So there is the keys there are private and public keys which are shared between the operators and the ops guys. Okay, so let's apply this to get this started. Okay, so this starts, and in the meanwhile, we'll take a look on the what we do now. So this is a cloud automation instance. This is the commercial version of Captain, but it works the same way on Captain itself. So when we take a look on this Git repository, which we refer to now, is that we have a lot of YAML configurations in there. So at first I have to, I created a custom resource definition for the instance, because the GitOps part of Captain and Captain do not necessarily have to run on the same cluster, and this enables some use cases as you might have the whole Git components in your lab and access your internal Git repositories, but you can also have a managed Captain installation or a cloud automation installation. There we refer to an API, to the Captain API itself, and we have the token also RSA encrypted. So everything we have here is RSA encrypted. Furthermore, furthermore, we have a lot of other custom resources such as project sequences and our services. And one thing in there is that we define the service itself in one custom resource and the service deployment in another one. And this gives us the possibility to always declare which version we want to deploy in one point in time. Okay. Furthermore, yes, we define all our stages, and we define some kind of sequences. And sequences are the processes Captain follows when it deploys something and when it checks something. And this is a thing we might see in the demo afterwards. Yes. So we define that we have some kind of monitoring configuration in there. We have a deployment, test, evaluation, and so on. And afterwards, we could also do a release of all of this. And these are a lot of custom resources we defined to control Captain in a declarative way, and our Captain operators know how to deal with this. And we can take a look on this also in Captain itself. So let's take this one. So when we take a look on our Captain instance, we got a project called Potato Head created by pointing Captain to this configuration configuration repository here. This created one service. This is the Potato Head, and it also triggered the deployment for this service. So it triggered our artifact delivery, which consists of a promotion step. This is more of a helper step to get everything in place, that everything works. Then we have Monaco. This is a Dynatrace open source project to do some monitoring configuration as code. Furthermore, we do the deployment. So the whole Potato Head will be deployed, and afterwards we test. We do some tests and try to find out how the system behaves. And this takes a bit. And afterwards, we will do the evaluation to find out if everything is okay. So the evaluation is running against our monitoring system, in our case Dynatrace. And if everything is okay, then the deployment will go forward to the next stage. Otherwise, if it doesn't work, then everything will break. And yes, when we're combining everything of this in a blue-green fashion, then nothing should happen to productive systems. In another way, we could also do rollbacks if deployments fail. Okay, then let's get back to the presentation. Okay, so what did we see today? So we pre-created some kind of configuration. So you saw the configuration I had in the repository. I applied only one custom resource for the Git to get everything in my cluster with encrypted secrets and so on. And after I applied this one resource, everything can be managed in Git. Sorry. Furthermore, this creates the whole Captain configuration and deploys the application if you wanted. So when I want to deploy everything to a next cluster, to a new stage, or to another cluster, it's absolutely no problem. I can recreate it and everything works. In our workflow, and let's see if we see this today, we can deploy also this to a second stage via custom resource, but also automatically. And yes, what I didn't show you today was we could also create a second service deployment for another stage, but the context will be maintained. So you will see the second stage in the same screen as the first one. And yes, you can also drop the custom resource for the project, and the whole project will be cleaned up. So kind of reconciliation afterwards. Yes, so what I said before, this whole project is currently work in progress. So it gets better, and there are always new ideas and so on. But we are always looking for new ideas and opinions. So if you want to try it out, everything is in GitHub, and yes, you can simply try it out. And for me, it would be interesting if you have some ideas, opinions on it, and how we could make this better. We are always looking for contributors at the Captain project. So if you have some ideas to build a deployment process the way you like it, just feel free to raise a PR. Just feel free to talk to us, reach out in the Captain Slack, and so on. Okay, so I think we're done. I hope you enjoyed the talk today as much as me. And just a second, I'll try to find out if my process is finished now. Yes, so this didn't get finished in time, but yes, I'm open for questions now.
Hello, Thomas. Welcome back on the live stage. Amazing talk. Also, some really nice drawing skills regarding your patterns, I must say.
Thank you.
So second career path as technical illustrator, maybe?
So if the whole thing with the cloud doesn't work, then yes, it might be an option.
All right. So you said you are open for some questions now. So maybe do you mind sharing with us how your tech career started?
How my tech career started? So I think I started in IT at around 1997. And I started as an apprentice, as a wholesaler, and was very, very enthusiastic about IT stuff. And almost in my apprenticeship, I worked the most time in IT. And for me, it was clear I want to get a systems administrator. And after my apprenticeship, I started as such and worked in an Austrian publishing company. Started as a support technician and ended up as the operations lead of the company. And yes, in the end, it was much management stuff to do, and I learned about Kubernetes and about everything which is cloudy, and thought that this solves all of the problems I had in the last 20 years. So from high availability to resilience and so on, and to scalability. And yes, then I started to switch to the cloud. Started at Dynatrace also as an automation engineer, and yes, now I'm innovating at Dynatrace for Captain and playing around with such things as Captain operators and other things, and I'm also responsible for the internal adoption of Captain at Dynatrace.
Okay, thank you for sharing this with us. You mentioned Dynatrace a few times, your current employer. Would you mind telling us how a typical workday looks like at this company?
Yes, so I think it depends on which team you are. So Dynatrace is a company which I think we have a lot of developers here. So I don't know the current number at the time, to be honest. And when we come to the office in the morning, there is almost everything in stand-up where we share our progress and where we have our problems and so on. And yes, then we work as a team on development projects, on new issues and so on, which are almost very interesting. So we are the market leader of observability, and we are always trying to get innovative solutions, and therefore it never gets boring, to be honest. So there's always new stuff to learn and always new stuff to take care of. And yes, this is the thing we do all the time. We are working in compact teams, so it's not one development teams of 100 people. My boss knows me. I think every boss at Dynatrace knows his employees. Therefore, it is unfamiliar environment here. And yes, for me, it's a perfect place to work.
Happy to hear that. Awesome. Also, I have a question right here from David. He wants to know, what are the main advantages of Captain from other similar products?
So I always hear the question, why should I use Captain and why should I not use Argo CD or Flux or whatever? And for me, it's not if we should use Argo CD or Captain. So for me, Captain is an orchestrator for the whole deployment process, and it can be used to orchestrate Argo or to orchestrate Flux. So to be honest, it's operating one step above Argo, for instance, to orchestrate such deployment tools, and it combines a lot of toolings to get the deployment process done. Furthermore, it's also cool that Captain uses the same workflow for every service in one project. So we are onboarding some services at Dynatrace in around 5 minutes, because we don't have to maintain the whole pipeline code. The pipeline always exists, so there is a Captain configuration for that, and we simply have to add the new service there without creating some pipeline code. So it's also here to deduplicate exactly this code.
Okay, thank you for that elaboration. Maybe also you mentioned that you work in the industry for some time now, but do you still remember the first machine or computer you worked on?
Yes, I think it was my father's one. So,
as usual.
And I think I destroyed it very often from a systems perspective.
But you didn't mess up the hardware, so
no, always on an operation systems level, okay. And I think it was 486 with 33 megahertz.
Sounds awesome. I have another question from Marty. Are you using Captain for your core product deployment?
Not at the moment. So we are using Captain for newer projects, but not as Dynatrace is a bit as the core product was developed a bit before that. We did not get it. We did not migrate this until now. But there are also efforts to do this.
Okay. So maybe are there any other resources regarding your topic you want to share with us, like maybe blogs, YouTubers, books, something like that?
I think I did I did a similar talk as today for the Captain community around 2 weeks ago. This I can share with you afterwards. And furthermore, yes, there is the Git repository of the whole GitOps stuff, where you can also take a look on. This was referenced in the slides.
Okay, thank you for that. We have another question. Do you have experience or running projects in automating and orchestrating blockchain node deployments with Captain?
To be honest, not.
Okay, short answer. But Marty has another question. I see. Is the Captain works? Does the Captain works with OpenShift 4?
I did not try it, but I think it should.
So let's try it yourself, Marty. So.
But yes, if you have such questions, you can always reach out to me or to other Captain developers on the Captain Slack. I think I also referenced this on the slides, and would be glad to help and to find out if this really works on OpenShift 4.
So let's find out together. All right, Thomas, I hope you had some fun today presenting.
Yes,
It looks like you had. Thank you so much for joining us today and have a nice day. Bye. Till next time.
Yes, you too.
Bye.
Thank you. Bye-bye.
Thank you. All right, peoples, now that our first awesome speaker is finished, we will have a short break of about 10 minutes and stay tuned as we have 3 more speakers waiting for you.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, welcome back everybody to the We Are Developers Cloud Day. I'm very happy to announce the second speaker. He is developer advocate at CircleCI, loves to educate and inspire developers on CI/CD, DevOps, and software quality. And as a matter of fact, he has a passion for craft beer. Please welcome with me, Sam Markan.
Hi, everyone.
Hello, Sam. Happy to have you. How are you today?
Great to be here. Yeah, I'm well. Thank you.
Awesome. Would you mind asking me where are you from joining us today?
I'm joining you from a very cloudy London, pun intended.
Thanks for that. So, Sam, apart from making good puns, you're also a pro when it comes to other clouds. So, would you mind telling us about what we are going to hear from you today?
Yeah, so my talk is essentially a collection of ideas and tips and tricks, to be honest, about how to be the most successful as you can with your CI/CD setup. So from your integration, automated testing, all the way to deployment and obviously security as well. And not only as an individual developer, but also as a team, and empower the whole organization through your kind of applying those kind of DevOps, CI/CD best practices.
So very important stuff, I would say. Okay, without further ado, I would say, Sam, the stage is yours.
Thank you. All right. So yeah, as the name suggests, practical tips and tricks and things that you should probably follow. But before we get into the deep end, let's have a little thought exercise and a trip down the memory lane. Have a think about a time when you released some software, and how was that feeling? Was it exciting? Were you scared? Is it a mundane thing for you? Is it just like something that you do all the time? Especially if it's like a bigger release happening. I tend to picture it as just like waiting for you to press this big red button, which will unleash all the automation that you have in place and essentially get your software that you worked on for, I don't know, maybe a week, maybe a couple of days, maybe a couple of months. It will unleash it into the hands of actual users. So yeah, let's do it, right? Let's press this big red button because we've done everything, right? We're ready. Where all the tests are passing, security is happy, the whole organization is ready to release this big new feature, and yeah, it's just waiting for you to put it live. So let's do it. This big red button has a nice audible click, nice tactile feel to it, like a mechanical keyboard, one of those clicky ones. So it's just like that, and off we go to the races. And it's out of your hands really, because you've released this is now going live to your users, and you can't really turn back at this point, can you? What you can do is just wait, sit in silence, and look at the dashboards, see what the users are actually seeing, and see if there's any issues with it. So yeah, after the first few seconds, you have a couple of options. Option one, you continue nervously looking at the dashboards and holding your breath until it becomes uncomfortable and you go purple in the face. Hopefully you don't, but anyway, just waiting to see if this inevitably blows up, and how it's gonna blow up. any crashes, any reports, any bad reviews on an app store, for example. Or the alternative is you pack up your stuff and go home or to the pub or whatever. It's Friday, 4 p.m., 5 p.m., and yeah, you can enjoy your weekend. I don't know about you, but I definitely prefer the second option. It's definitely better on your happiness, on your well-being, and yeah. And there's not too much difference between the option 1 and option 2, because, like, as I said, you've got all your code tested, everything has been checked, everything's been verified, you're ready, you've done all the work. And the difference between the two is just like in the amount of automated processes that A, you have in place, and also B, the amount of trust you have in those automated processes. Do you trust them or you don't really? And that's going to be the difference between you doing something on a Friday afternoon or doing something nervously on a Tuesday and hoping not to salvage the whole operation by the next couple of days. Anyway, and this is not only true to software. This is really true to every single industry, every single field that we might be working on. So from manufacturing to business processes, and yes, all actual fields in the agricultural sector. And while this talk is not about agriculture, far from it, I do like to compare software delivery lifecycle and just software development, the process of that, to growing crops. You constantly need to be investing and working in it in order to literally reap the benefits. And the same as with a field like this, like I don't know how many hectares this is, but it's a pretty big field. You can do everything manually. You can have dozens, hundreds of people plowing this by hand, planting the seeds, then weeding, then watering, then doing all the things that we do, and ultimately, yes, harvesting and reaping things by hand, and do the same thing the next season. Or you can do it a lot faster with a lot fewer people and a lot more predictable results by employing some level of automation. For example, you can have you can use tractors to do your plowing of the field, which will kind of make your ground a lot more fertile. You can put irrigation systems. You can have automated harvesting machinery to actually do all your harvesting for you. And each one of these things will A, require less people, and B, make the end results more predictable. And that's ultimately what we're getting after, because the same with software. And if you take this a couple of steps or a couple of dozens of steps further, you end up growing your crops in this highly automated greenhouse scenario where you're controlling everything. You're controlling the light, the humidity, the temperature. I would imagine each individual of these plants that you see here is getting fed directly the right level of nutrients that they need for optimal growth. And I would imagine that these robot hands that look really, really cool, what they do is use computer vision to essentially figure out which plants are at their ripest and when, so that they can pick them up and package them, and you can ultimately sell them at the highest profit. And that, to me, is a really good analogy to a really finely tuned CI/CD process. Everything is happening in this kind of hermetically sealed environment, infinitely reproducible, very, very much automated, and you're just really just picking what gets planted and making sure that you're kind of supplying the seeds, quite literally, and then just reaping the benefits. And yeah, this is what I like to compare this, because think about it: if you execute things in like reproducible environments, this is what you're going to get. Of course, not everything goes to plan. And while I don't think that our robots that are planting our crops are going to turn into these kind of giant robot dinosaurs, turn against humanity and bring us back to this really cool looking Stone Age with bows and arrows and robot dinosaurs. They can certainly misbehave in ways that will ruin your crops. And yes, your software delivery automation can misbehave and ruin your user's day and ultimately ruin your day as well. But fret not, because it's never the machine's fault. It's always us. And the reality is, it always boils down to human error. Machines don't really program themselves yet. It's us doing the scripting, it's us doing the maintenance, and us ultimately doing everything that's wrong with our processes. My name is Markan. I'm a dev advocate at CircleCI, and I've broken way too much software to count. Anyway, if you like this talk and you want to ask me a question, whatever, do reach out to me. I'm pretty active on Twitter, or Zan at CircleCI if you want to email me any questions, etc. Anyway, I mentioned that I work for CircleCI, and so we are the leading CI/CD provider out there. We've been around for over 10 years now, from before CD was a thing. So when we were just doing continuous integration, and grown with the industry essentially, so that we're supporting teams all over the world in their delivery and building of software better, faster, and ultimately more successful. So whatever technology you're using, whatever stack you're using, whatever you're really deploying. So whether you're doing microservices orchestration deployed to Kubernetes, or you're doing like static websites, or you're doing mobile apps, or your organization is doing everything, we can probably support you. But this talk is not about CircleCI. This talk is very agnostic of the technology that we'll be discussing today. And first, let's just kind of disentangle the acronyms a little bit. I'm sure that most people watching this will have a deep understanding of what CI/CD is, but it's usually still good to kind of point out a few important things. So CI/CD, a double acronym where CI stands for continuous integration, and it's the process of running automated checks, verifications, and tests on each commit that gets sent to a main repository or a shared repository, and which ultimately results in a built piece of software, or notification that a build has failed because some tests have failed, some scripting has failed, or something else has gone wrong. So this is like an automated process, hooks into your development flow. So you're using GitHub, for example, you commit stuff, and you get feedback saying, hey, your software has been built, or your software hasn't been built. Whatever you're testing, whatever languages you're using, it doesn't really matter. What matters is this process. We can also include a bunch of other things in there that aren't necessarily just testing the kind of logic of the code. We could be scanning for vulnerabilities, for example, a bit more on that later. You could be doing static code analysis. You could be doing coverage analysis, all sorts of things that results in ultimately you having more confidence in the software that you build. Another thing that's important here is that we are defining not only what needs to happen, but also where that needs to happen. So remember that greenhouse that I talked about earlier. So you're defining exactly to the letter. This should execute in this example Docker container based on this image with this exact version. So it's kind of really set in stone, or like encoded in a commit. So it's like immutable in the history. So in theory, every single run of this kind of CI flow should result in the same thing based on the same code, because the last thing I want to point out is that the way we configure most CI systems, including CircleCI, is we configure it as code. We use YAML, and we stick that YAML configuration file in that repo. So it's kind of tied to the same commit. Everything is scripted. Everything is done alongside your project. So yeah, same commit, same history, same results every single time you run it. That's the theory. Once you build your software, you obviously need to get it into the hands of users. So that's kind of that big red button where that comes from. And that's the continuous deployment part. And yeah, that's ultimately all there is. So provisioning infrastructure, deploying your software to different environments, whether it's test, staging, or even production, pre-prod, where it gets to real users, whether it gets to testers. It doesn't really matter. What matters is that you're kind of scripting this and including this in your flow so that it's part of your whole CI/CD pipeline. Essentially, you commit some code, and that results in a push to production and something going live somewhere for someone. And that's really what we're talking about. And yes, there's a lot of things that we are talking about, and a lot of dimensions where we could be either successful with it or unsuccessful. Hopefully not unsuccessful. But anyway, in this talk, I will be I'll be disentangling this kind of whole process and looking at various parts of that journey, various dimensions, and how you can be successful in every single one of them. Because by doing that, you'll be successful in all of them. And not only as an individual developer, as I mentioned in the beginning, but also as a team and ultimately as an organization. First one is probably what's most obvious to everyone who's ever used a CI/CD system to get any kind of feedback on their code that they're shipping or that they're writing, is how fast does the thing run? How quickly do we get results from it? And definitely, yeah, speed is a very, very, very important part of everything. And yeah, the faster we get results from our CI tool, from the CI step, is the sooner we can continue working on the next feature, the sooner we can continue reviewing our colleagues' code, the sooner we can move on, and we're just not bogged down by waiting on something. But that's just like one small part, because speed is a huge, huge topic here. The other one that I'll be kind of going a bit deeper on is time that it takes to recover from a failing build. And that's ultimately even more important, especially if your software delivery depends on you going through all those kind of CI/CD steps and automating everything. If your default branch, whether it's main, master, whatever you're naming it, whether that's failing, if you take, I don't know, longer than, I don't know, a few hours to recover that, you cannot ship any changes. Like, and I've been in that situation. We couldn't ship any changes to our code, even though we knew we had bugs in production, because our CI CD was broken on our main branch at the time, and that's not a place you want to be in. So it's the time to recover from a failing that you should really try to limit as much as possible. And yeah, as I mentioned, organizational things, the time to ship a feature. So as we will talk about a bit later, is with CI/CD, if you have that in place, all those checks, all those verifications will happen automatically, so you can actually ship smaller features and smaller chunks of code. And you get feedback. You validate those kind of changes that you ship sooner rather than later, so that it really shrinks down the time it takes from your product manager saying, hey, we want to add a new feature to our search product, to that kind of feature going live to the actual users. And that's obviously beneficial for the organization. And lastly, not something that's obvious, but very, very, very big benefit if you're adding new team members, whether it's your new hires or people who are moving from different parts of the organization, the time to onboard. So if you have a big piece of software that you're working on, a huge kind of source code base, basically, you can either point someone to an inevitably stale piece of documentation, and yes, all documentation goes stale, or you can point them to a operational CI/CD pipeline configuration and tell them, hey, look at this. This is the test we're running. These are the scripts we're running. This is how it's all laid out. Have a read, have a think about this, and then we can have a conversation if you have any questions. Like, so it really kind of helps you increase the initial level of understanding with anyone who's kind of new to your team. And that's like immensely valuable because we all want to go faster all the time, right? So yeah, speaking of running our pipelines faster, so getting that kind of feedback as soon as possible, there's a couple of things we need to do. First one is think about where you're executing things. If you're using a cloud-based provider, it's quite easy to just use whatever different resources they're using. And especially with like compiled languages, like things that work on the JVM, I use a lot of Kotlin, for example, and use Gradle. That's all kind of multi-threaded. It takes a lot of RAM. So just think about whether you're giving it all the resources it can, and understand whether you're using those resources as well as possible. Because yeah, if you have 2 cores available and 100% on both of them, maybe you can just increase that. It's going to go faster. The second one is do things once that you were previously doing twice or multiple times. And that's obviously utilizing caching. And what's caching other than saving work and then avoiding from redoing it? And that includes things like dependencies caching. So every single software that we built, it's not built from scratch. It's built using existing dependencies, whether that's open source libraries, proprietary libraries, tools that you ship for yourself. If you have a package manager, and you probably do have, in whatever you're using, for example, Node.js has NPM or Yarn, they will, you specify your packages, for example, all the dependencies, and that will generate you this kind of log file, which kind of really sets in stone all the versions or all the dependent versions, etc. Once it kind of resolves those. And if that log file does not change, your dependencies have not changed. So you can safely cache those and save yourself a re-download every single time, because caching locally means that, yeah, you're just transferring them effectively from the same kind of cloud provider to the same cloud provider. So a lot faster operation all throughout. And that doesn't only end there. It's also caching things that you've already built. So, for example, if you have an artifact that you've built that's, for example, a Docker image that you then want to run some tests and you then want to run a security scan on, just like make sure that you're kind of passing that along. Obviously, with the Docker image, you kind of reuse the same thing in the registry. But if you're doing like a binary that you're building, just pass that along and move it along your jobs in your pipeline, in your workflows, so that, yeah, you can redo the same amount of, you don't have to redo the same amount of work, but you can still do all different things in parallel. Speaking of parallel, is, yeah, apply as much parallelism as possible. Again, with cloud based tools, it's very easy to run like 10, 20 things in parallel. And obviously, they are the things that aren't going to run sequentially and aren't going to take are going to take much less time because of that. So yeah, that's just one thing. So like all the different tests that you have, run them in parallel. All the different verifications like security scanning, linting, etc., run them in parallel. And only when you really need all the dependencies to pass, then have something that's like a dependent job on all of them. And that's kind of like top level workflow orchestration. The other one is think about whether you have really long-running test suites. By that, I mean like 20, 30, 40 minutes or like hours. I had one that lasted for like 8 hours, functional tests. And if you can split those, like we do offer something called test splitting, essentially. It will figure out, depending on what kind of parallelism you have, the correct kind of combinations of tests that you run across different machines with very little modification to your pipeline. And that's like a very easy way to really kind of quarter or even like decimate the time that you are that you're taking to run your long-running test suite. And that's obviously faster feedback for you and everyone else on the team. And lastly, it's thinking about what needs to run. So if you have like extensive test suites, like everything that you could be testing, like especially like long-running functional tests, smoke tests, analysis of these tests, don't maybe need to run at the same time as you are waiting for just like correctness feedback on your commit. Maybe you can run them nightly, hourly, essentially outside of your kind of normal commit check flow. So yeah, like figure out what can go in an asynchronous way, maybe like deployments of your kind of working alpha releases or something like that. That can definitely go in daily or nightly pipeline, for example, as opposed to every single time. So yeah, that doing those 4 things is going to really help you speed up your pipelines. If you don't have a problem with that, I'm really, really happy, because it tends to be that most companies do struggle with this. Most teams have some issues with their pipeline times anyway. And yeah, obviously, pipeline times are fine, but annoying when you actually need to get from A to B and you're stuck in a gridlock. This is London, and this is Google Maps overview of some of the streets in central London on a good day. And like half of that is red, which means that half of that traffic is like really gridlock. If you have a combination of an issue on the public transport, like a signal failure, which we do have multiple times per day, this goes a lot more red, as a lot more people are using Ubers, a lot more people are using taxis, etc. But what this means is that, yeah, ambulances can't go fast either, because they're stuck in the same traffic as everyone else. And yeah, this is a situation you really want to avoid or minimize as much as possible in your CI/CD pipelines, because yeah, when you do have a failing pipeline, so like a failing piece of infrastructure, yeah, get that back as soon as possible, because you might need it sooner rather than later. For that, there's a couple of things we can leverage our CI/CD tool for. First one is, yeah, just understand how to use it to gain all the insights that you need into what's happening with the work that you're achieving, that you're doing. So use it to identify bottlenecks, which are the slowest jobs, which are the most likely jobs to fail, maybe even locate flaky tests, like tests that don't operate deterministically, but there's some kind of flakiness element to it. That's all possible. That's all like real features that you can utilize. And by doing that, you will just understand where the problem is sooner, and you'll be able to look into that problem a lot faster. So waste less time on that and focus more on the actual resolution of that issue. Speaking of resolution of that issue, there is a few things that we can definitely talk about as well. First one is understand how you're going to get the information out of your builds, out of your jobs, out of your test runners. That's obviously using logs, but it's not just like how do we log things, but also how do we log things in a verbose manner? Like what's the level of verbosity that we need for this? And that's one thing. And also, how do we get these logs out in order to process them asynchronously outside of our normal flow? So if you want to grab something through logs, how do you do that? How do you really kind of analyze those logs faster in order to really pinpoint the failures and figure out what's wrong? The second one is like, get the artifacts that you're building, that you're working on, especially if it's like a test failure. Get them out as soon as possible, and maybe you can run them locally in a different environment, see by yourself what's gone wrong in order to actually resolve this. And lastly, if you have the ability, see if you can SSH into your running jobs. Like we have this feature called SSH debugging, essentially, which allows you to spin up a job with SSH turned on, and that will let you debug the failure as it's happening in that same environment. So it's not really like a hermetically sealed greenhouse anymore, but it's a greenhouse that you can actually go in and analyze and look for all your kind of broken little issues that can help you identify the problem and then fix them in the next run. Because everyone knows that fixing a broken CI/CD pipeline, especially when it's something like piping related, it's really annoying, because you most fixes happen by just triggering a number of builds in a rapid succession, waiting on them to complete in order to figure out what's gone on. And if you can debug things while they're live, that's really, really valuable as well. So that was speed. But then, when I said, I gave you the race car analogy in the beginning, how we're trying to go faster by all means. I lied. It's a trick. It's not the goal is not to be the race car. The goal is to be one of those things. So like an ambulance instead, because yes, you should absolutely go as fast as you can, but also considering the payload that your pipeline is carrying. So all the tests that you're running are going to be how confident you are in them. Like the more tests you have, the better level of confidence you have. So that's the actual signal that you're carrying. So the strength of that signal means the confidence that you have in your pipeline, in your product ultimately. And yes, when you see the red lights, move it out of the way and go fix it as soon as possible, because broken builds are bad. Okay. So this kind of concludes the speed section. I know it was a big one. Next ones are going to be a bit shorter. The next big topic is security. So securing CI/CD pipelines and how to get the most out of your platform so that your software is as secure as possible is, again, a very, very big topic. So we have a couple of things that you can lean on, essentially. First and foremost is using a CI/CD tool to keep your credentials safe. So by that, I mean, keep them out of your Git repository, because no credentials are safe if they're stored in your Git repository. By having them in your kind of build or deploy process instead, it means that they're only injected when they are absolutely needed and kept encrypted until then. That's like the most basic but the most important thing that you can think of. The other one is automating security scanning processes. So there are tools available, like plenty of tools available that will do dependency vulnerability scanning, that will do SAST, so static code analysis, static security scanning, DAST, which is like a dynamic security scanning, and you can implement those tools. You can integrate those tools in your CI/CD pipelines and get results right away from those tools in your CI/CD pipeline. The same as they're telling you, hey, your unit tests have failed. Hey, you're trying to ship a new dependency which has a known vulnerability, which will impact your users. And that's like really, really powerful. If you're using any of those tools, if you're partnering with any of those companies, like have a think if they have some way to plug it in into your CI/CD pipeline. Usually you're just scripting things. So there's definitely a CLI probably, or something similar that you can just use and get the results out, because obviously that's going to be the security scanning that your team is not going to have to do later on before you're releasing. The next couple of points rely on, talk about how do you deal with access, and how much credentials you can give to your running jobs. So principle of least privilege, for example, means that if you're injecting all your credentials, for example, your API keys, your deployment credentials, move them to where they're absolutely needed and outside of where they're not needed, for example. So only the job that does the actual deployment to an environment, for example, your AWS stage, AWS prod accounts, only those jobs really should have those credentials, and the rest should not. The next one is just like the same as with different jobs. It's just like thinking about whether you can limit who on your team is able to do certain things. For example, prod is pretty important for everyone. So maybe think about how can you limit the access level of who can actually push a commit that will end up in prod. What kind of checks you need to do. Usually that requires not only the CI/CD part, but also setting some kind of protected branches so that your main branch is more protected, so that it needs a review, it needs all of those checks. But ultimately, you are kind of in control of who from which security groups can actually trigger a deployment as well. So that, everything is automated, but it's also restricted in a way that makes sense for your team, your org. That's not necessarily need to be the development team. It could be the security team has the right to do a manual approval, for example. Hey, they've done the audit, they've looked at all the security scanning things, but only a security team member can actually go in and hit a manual approval. And that's my last point. It was like, not everything needs to be automated. Some things that are automated should and could definitely still have manual processes, manual steps required. If like an organization requires it, absolutely. Have a manual step saying, click here if you're really happy. That's going to be tied to your username. It's going to be tied to your account. So you still have the whole audit log that you have in your Git commit flow, but that's like the extra level of security, extra level of assurance for many organizations that they need from a CI/CD perspective, which will in turn allow you to have a nicer pipeline for everyone. Speaking of pipelines for everyone, it's blatantly obvious that we're not only talking about the development team as the teams that are using CI/CD. It's the whole organization that is interested in A, making this work for everyone, and B, benefiting from it. And the whole organization should be interested in your team being the most successful in your CI/CD usage, because ultimately, every change that we ship, every time you're looking at the dashboards when you're shipping something, you're essentially validating all your changes in production. And that's just the reality of things. And just embrace this idea that that's going to happen. But also, what you can do is, how do you use your CI/CD tool to make that kind of validation a lot smoother? And for that, I mean, you're probably using a tool for dashboards, for analyzing your usage metrics, for seeing all your errors. So why not just use your CI/CD to flag any deployments that are happening? So this is the new version we just released today at 2 p.m. And since then, have you seen any new errors happening to your users? And that could be like a full-on deployment. You could be using like a canary approach. It doesn't really matter. You can figure out what works for you, and just kind of how do you flag these things from your CI/CD tool. And the same way going back from where your product manager is sitting. So they want to know, hey, has this bug fix been deployed? Yes, of course, because maybe you use like a Jira ticket or something like that. Just go send that signal back to the Jira ticket. Hey, we've done this deployment. This bug fix should have been corrected in the release 3.2.11. And that's great, because that's the information that's making this kind of CI/CD tool valuable for everyone and visible that it's valuable for everyone. And ultimately tie into your communication flows. So if you use Slack, for example, and you need approval from someone to look into your code and say, hey, this is okay, this should go ahead, just ping that person on Slack as well. And that's going to shorten your deployment flows as well. And that's going to make everyone's life a lot easier, because the communication flows smoother. It's where you actually need the information to be. And So think about who else apart from the development team can benefit from this. Thinking about teams, obviously, can't be a DevOps talk without talking about people. And that's my whole point. CI/CD is the whole organization's responsibility, not just your teams, not just you as the sole maintainer of CI/CD systems, which is like the worst thing you can actually do. Just spread the word about benefiting, who can benefit and how they can benefit from your really finely tuned CI/CD process. And spread the knowledge about maintaining these pipelines throughout your team, so that, yes, you're not the only person that everyone relies on while you're on holiday, that they can come in and fix the pipeline, basically, because no one wants that. And it's just dangerous, and it's really bad for business, for everyone. Making sure the whole organization knows the benefit, the whole team knows how to use it, how to get the bits out of it. And it's not just like, this is just frustrating us because it's slow, but this is actually giving us all the assurance that we need. This is the tool that's really making us a lot better developers altogether. And I mentioned this in the speed section as well, and worth reiterating. CI/CD configuration is an onboarding aid. Obviously, some of those deployments from the beginning do crash. And sometimes we need to go in and fix things like 2 minutes until midnight. And that's just reality. And broken deploys will happen. But what we can do is make them mundane, make them something that's just like, we've done a broken deploy, so what? We've reverted it in the same breath, basically. And that's something that you can really, really benefit from. Because if everything is tied from a single commit, encoded in the whole kind of steps are encoded, the infrastructure provisioning is encoded in the same kind of flow that you have, you can really just go back a couple of commits when you know the version was working, re-trigger the pipeline, and maybe your software can be fixed in just like a matter of minutes, which obviously allows you to go back to sleep and fix this issue on the next day when your team is awake, your team is not in a full-on crisis mode, which is definitely beneficial for everyone. Because the more kind of you have to work with this kind of sense of urgency, crisis mode, the more mistakes you're probably going to make. And again, that's just going to compound the level of insecurity that you'll have about your CI/CD pipelines. And the more you're ready to do these kind of small deployments on every single commit, the lesser the chance that your changes are going to be like very negatively impacting for everyone. And my best point for how to actually get this to work for you is to just have a playbook, have a plan, and practice for it. Like, let's say we'll do a practice run with our team of a broken deployment, see what happens in the ops, see how you get paged, see how you will act when something like that happens, and yeah, do these runs like every few months. You'll be in a really good place if you actually need to revert something. Hopefully that doesn't happen, but it happens to everyone. Which brings me to my last and final point, which is to be successful with CI/CD tools is to be free. And it allows you to deliver software on the terms that you control, that work for you as an individual, as a team, as an organization. And it allows you to focus on software quality, really driving the value to your users, and also, yes, to well-being of your team, because they're not frustrated by some processes that could have been automated or could have been automated better. Your companies are going to be better adapted to any changes. And yeah, you have a self-documented process, which is encoded in the same flows that you're using for writing the actual code. And yes, you can recover from failure faster. So that was my handful of practical tips and tricks for succeeding with CI/CD. I hope you found it valuable. If you want to see numbers and stats, we do publish this report called State of Software Delivery, which basically collects the data from like dozens of millions of pipeline runs and jobs every single year. So we just released one from 2022. Well, the data is from 2021, but which gives you kind of benchmarks for comparison against like teams in various different industries, using various different technologies, essentially looking at what makes sense. We do offer some kind of ideas for metrics. It's free to download. You don't need to register. So I definitely recommend you have a read. And you have some feedback from me. If you want to see slides, or yeah, if I can send you some swag as well, do reach out to me at CircleCI.com/Zan, and there's a form where you can do that. Anyway, that was Zan Markan, and this was the practical tips and tricks for CI/CD success.
Hello, Zan. Welcome back on live stage. Awesome presentation. You have a really light-hearted presentation style. I really enjoyed listening to you.
Oh, thank you.
I totally love the Monkey Island reference. So awesome. Have you heard that Ron Gilbert is actually developing next part?
Yeah.
Yeah, they announced this every April Fools, but it's happening.
Yes, exactly. I had the same thing. It was like, I saw it on like the 4th, I think, and it was like, this is 3 days old, maybe? Hope not, but it's not. It's happening.
Exactly, it's happening. So looking forward to this, obviously. So we have some time left for a short Q&A. Maybe do you want to share with us how your tech career has started, how you came to be?
Yeah. So, sorry, I had some distractions in the background. Could you repeat this question? How my tech career has started?
How your tech career started? Yes.
Yeah. So I'm pretty boring, to be honest. I studied informatics, so didn't come from a more exciting career. Yeah, I actually started to start up out of university and moved to London and yeah, worked as a developer, team lead for a number of years, and then I kind of ended in developer tools and developer relations.
Okay, nice. Another question from David. He wants to know what security problems happens most often in real-world scenarios.
I mean, every single year or every single couple months, we hear about some kind of open source library kind of being compromised, because you know how open source is, right? There is like one maintainer, and they get like a large number of PRs. And there's all this pressure to just merge and release all these things. So there's like very easy to kind of add malicious code to a very popular open source projects. And like there's like I forgot, it's on the top of my tongue, but I forgot the name of the last big one with the SSL. It's like a big vulnerability, and just like small things that happen, and And that just kind of like has this huge impact on the whole point of the whole myriad of industries and companies and everyone who's using this. So yeah, that's like the biggest one, just insecure dependencies. The other one that comes to mind is just like tools that might actually leak credentials or information, again, usually through some insecure dependencies on their own. So it's always something like to do with that, just because we have so much software that's developed in the open, and for better or for worse, to be honest.
Okay. Thank you for these insights. Since you are a gamer, obviously, maybe do you remember your first computer that you have worked or gamed on?
Oh, that was like a 386 probably.
Okay.
Yeah, it was old machine. It was like good times. But I prefer the newer stuff, to be honest.
You prefer the new stuff?
Yeah.
Yeah. Since you can emulate the old stuff on the new stuff, you don't lose anything.
Of course.
All right. San, do you have any further resources you want to share with us about your topic? Maybe books, blogs, YouTubers, something like that?
Yeah, I mean, obviously, like I've already mentioned it. I do recommend everyone who's not seen it, check out the State of Software Delivery. It's, as I said, it's like free to download. There's no sign up required, and it's just this super interesting read. It's a report that we do every single year. And yeah, it gives you just kind of like, this is the throughput that you should be looking at. This is the benchmarks for like pipeline duration, for how the teams should be structured, how the teams should work, etc. It's just like really, really good read, I must say. Okay,
I'll have a look into it. So we just got another question from Nats Vrats. Great talk, San, using CircleCI and really enjoying it. What is the product roadmap like right now? What is next to CircleCI?
Some really exciting things that I'm not sure I can talk about, but it's happening in the next few months. Definitely, we have some really, really cool releases happening. That's gonna like make CircleCI accessible to a lot more people, I would say. That's all I can really say, to be honest.
Okay, yep, sounds awesome. San, thank you so much for your amazing talk. It was a pleasure having you today. And
it's great to be here.
Yeah. Until next time. Bye.
Bye. Have a good one.
So, before our next speaker, the third of today, we'll have a short break of about 8 minutes. Stay tuned for more cloud speakers.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, welcome back everybody to the WeAreDevelopers live topic day. We have halftime, 2 good speakers finished, 2 to go. So, the next one is CEO at Darwinist, designed and built large-scale compute and storage systems for the supercomputing industry, and now he revolutionizes the way organizations invest in technical staff and work with external people. Please welcome with me, Andrew Holway.
Hello.
Hello, Andrew. Wonderful to have you. How are you today?
Very good. A little nervous, but very good. This is my first time doing this talk, so we'll see how it goes.
I'm sure you will do fine. Would you mind telling us where are you from? Where you are joining us from?
So I'm originally from the UK, but I've been living in Germany for the past 12 years, and I've just moved to Zambia. So I'm sat right now in Southern Africa in Lusaka.
In Zambia, so that's not exactly the neighborhood.
Same time zone, 13,000 kilometers away, but same time zone. So it's quite a nice remote working location. Let's put it like that.
Nice fun fact. So, Andrew, what are we going to learn from you today?
Generally, well, the work that I do is really about retooling technology teams. Retooling is an extremely difficult thing to do for a technology team. So a team has made a technology selection. They're using a framework, they're using a language, and they can create features and deliver value using that framework or language. But when it becomes time to swap languages or change core parts of the technology that you're using, this is always a bit brutal. And so so my company Darwinist, we're specialized in helping companies transition technologies. And so I'll be talking about some of the challenges and presenting a case study about how that can work.
Andrew, that sounds very interesting. I would say the stage is yours. Have fun.
Thank you very much. So let's see how I can control these slides. So yeah, my name is Andrew Holway, and I'm from Darwinist. So let's begin. So basically, yeah. As Benedict said, I used to build supercomputers for various large high-performance computing projects, such as the Large Hadron Collider. I worked for the Wellcome Trust for a little while, for CERN, all very, very big stuff. This means that I'm a fairly hardcore infrastructure specialist. I know what a network is, at least. I am a mediocre developer, like everybody, I guess, and I'm of course a failed CTO. But I've been working in technical consultancy for a very, very long time for companies large and small. And over the past 3-4 years, I've become obsessed with the concept of instructional design. And this instructional design now basically shapes everything that I do and the way that I work with customers and the way that my business works with customers. So let's click next slide. So instructional design, this is just copied directly from copied directly from Wikipedia this morning. But basically, instructional design is about designing instructional materials and experiences, and basically designing the acquisition of knowledge. This is basically designing learning. This is basically designing how people learn. It's defining a learning outcome and then working out how people get to that learning outcome. So everything that we do at Darwinist is delivered as a learning objective. I just want to reinstate that because that's the entire context of this talk. So jumping in. So as I was saying during the introduction, most teams are very, very good at developing features around the known technologies that they work with. So for example, you have a team that are using Python, maybe they're using Django, or they're using Flask, they're using MySQL, they're using Postgres, they're using an ORM, and maybe they're using a cloud provider, for example. They're able to quickly and efficiently create features using this stack. However, when it comes to doing new things, so say they find out, for example, that they need concurrency, and they need to move everything they need to start getting to grips with Golang, for example, it's quite a leap for a bunch of Python developers to be able to then start quickly and efficiently using Golang. Golang's honestly a bit of a nightmare to get started with, and you need to structure the project the right way from the beginning in order to be successful. So agile software development, Scrum, whatever, agile, the general agile thing, it only really works when we've made these core technology choices. You can't really apply agile to introducing new technologies. It's not designed for that, and it doesn't really work for that. People try and use it for that, but it's weird and doesn't work. Well, at least in my experience. So what happens is that typically you have maybe one or two software engineers, whatever, they go and do a research spike. So maybe they spend a sprint, or if they're not using sprints, maybe they spend one or two weeks. But there's going to be some kind of time box normally. But doing a spike puts really weird and strange pressure on an engineer, especially if this technology decision is going to be important. So a client that I'm working with right now, they're ingesting, billions of records a day, and so they're struggling to make a decision about what kind of database engine they want to use. And so they have to really think they're having to think very carefully about how they structure that decision, because just having one engineer making that unilateral decision, that's a really uncomfortable and difficult situation to put somebody in. And that core knowledge needs to be shared across the entire team. So introducing a new technology is really about finding the right pattern for that technology. It's about understanding what is the happy path for that technology. You can often nail your square peg you can often beat the square peg into the round hole. And, I work with a lot of clients that are sort of halfway through knocking in the square peg, and they're suddenly realizing, oh, now we've understood what this technology delivers, it doesn't really fit our original requirements. And this can often take months to really discover. You can be grinding away. For example, you're trying to do concurrency in Python. That's a classic one. Python's not the right language for concurrency. It just doesn't do that. But often it takes you quite some months to really discover how bad it is and how that fails. Discovering the correct patterns, finding these patterns, unveiling these patterns is really hard today, because the internet is so noisy. There's so many blogs, there's so many opinions, there's so much going on, and it's impossible to it's just too noisy. It's impossible to find an effective pattern. Often as well, with many technologies, their own document, especially with open source technologies, SQL Alchemy's documentation is a really good example of a really obscure, weird, difficult to use documentation. And many open source projects have really terrible documentation that's impossible to really understand how this technology is meant to be used. What's the best pattern? What's the best practice for this technology? And so everybody's kind of like piling pain upon pain upon pain. So some people will turn to training, for example. Now, training is a bit of a difficult proposition in technology for a couple of key reasons. The first one is this picture up here. I don't know if I've got a pointer. Do I have a pointer? No, I don't have a pointer. So this forgetting curve graph that you can see on the top right hand side. So we can basically see that we learn something, but then our retention of that knowledge drops off exponentially quickly. So that means after, if we learn something, that means after, a week, we're maybe retaining 30% of that. We can combat the forgetting curve by making sure that we have regular daily reviews of that knowledge. But does training really deliver that? So you go to a training center. If you're lucky, that training center has good quality labs, but they tend to bash through the content. And do you really get the reviews that you need to really get this knowledge properly assimilated? Also, technical knowledge is what's known as tacit knowledge. Tacit knowledge is knowledge which it's what we call tool using knowledge. You know, so using a lathe, for example, is tacit knowledge. Using a welding machine is tacit knowledge. Being a carpenter is tacit knowledge. This is knowledge which is very, very difficult to pass from one person to another using, this is very, very difficult. This is knowledge which is very, very difficult to pass from one person to another via the verbal or written form. This is stuff that we learn by doing. And all IT engineering, software engineering, all of it is very, very tacit knowledge. And this doesn't work very well in abstract training where you're taken away from your job. Tacit knowledge has to be built on the job. This is why you learn the most when you start working. Some people turn to consultants. I am also a consultant, but we're different, obviously. Consultants are very rarely concerned with helping a business to really invest in their staff. That's rarely their core. That's rarely their core value. When you use consultants or when you use outsourcing, you're invariably taking ownership away from your own staff. That's the way it works. You're giving this chunk of work, which you don't want to do, which you can't do, to a bunch of other people that are external to your organization. And the thing is when they're done with that bunch of work, somehow that bunch of work has to come back into your organization. And this is always incredible. This transition from external to internal is always very, very difficult. And when you're paying consultants, you're missing a trick because then you're not investing in your own employees. So I want to introduce a case study. This is DMSI. They're based in Nebraska in the US. They've been running since the mid-70s. They build ERP systems for the construction. They basically, I think they pretty much own the ERP system, the ERP market for the construction sector in the US. They've been going since the mid-70s, so they've been through several technology transitions. But now they're focusing on the latest. They're focusing on their latest push, which is Golang, Kubernetes, very, very modern stack. However, they managed to get very stuck with Kubernetes because they were just scratching around trying to find an appropriate pattern. I'll let you read the text here. So you can find the pattern that I gave to DMSI here. So you can go on GitHub. Please don't criticize the messiness of my GitHub. But right here in this repository, you can find the simple pattern that was delivered to them. It's not difficult. So if you want to grab that or take a picture of that, you can find that later on, or you can contact me and I can give it to you. So this is a tricky conversation. You need to be, I've been an infrastructure engineer, and some people would say a DevOps or an SRE engineer, whatever, for some time. This is a tricky conversation to have. Basically, Kubernetes, when I started working with Kubernetes, I realized that it automated away about 95% of my job. And I became redundant. So if you're using Kubernetes, if you have an effective pattern, what I'm trying to say is if you have an effective pattern for consuming Kubernetes, you shouldn't really need people who identify as a DevOps engineer within your organization anymore. It becomes a very, very difficult proposition. If you have a DevOps type situation that isn't resolved in less than a month, something's wrong, and you need to look very, very carefully about what's happening there. Even for quite complicated projects, you don't need excessive amounts of DevOps. In fact, that often provides a lot of weird abstraction that's difficult to get through. It often forces weird patterns on the developers. It's DevOps today is a very, very dicey proposition. It's very, very difficult and very, very weird. And DevOps as a role is something that must be owned by developers directly. And we'll talk more about that a little later. So as part of this, and again, this is I'm talking about I'm roughly talking about what was delivered to DMSI, the case study customer. But basically, you need to be very, very, very careful when you're getting involved in concepts such as infrastructure as code, when you're starting to use tools like Terraform, when you're using tools such as Helm. Now, I'm probably going against the bulk of people here. I'm not sure that following infrastructure as code doggedly as a principle is a very good idea for most projects rather. And I'll explain how Kubernetes enables that in the next couple of slides. If you're struggling with adopting cloud, try getting rid of these tools. Get rid of Terraform, get rid of Helm, get back to basics. Amazon Web Services CLI is a great tool, and it suits the AWS CLI also suits how Amazon Web Services works. AWS is an imperative platform. You have to do this step, then this step, then this step, then this step, then this step. And when you're using a CLI, when you're using the CLI tool, you can directly see, I'm going to do this step, this step, this step, this step, and this step. And kubectl as well, you can just use this directly. Like, there's not really any need to use any fancy templating, or there are specific use cases that Helm can help with, such as when you're distributing packages that are going to be on your customers' clusters, for example. Then there's some use cases there, but not really, in my opinion. So if you're getting lost, if things are going a bit weird, try and fall back to these basic tools, and you'll probably find that you'll start getting traction. So yeah, keep it simple, stupid is my key message here. So this diagram is meant to explain the separation of concerns between what we would call a platform team. So I'm dividing this up and saying that on Amazon Web Services, at least, a platform team is mostly going to be using AWS CLI or Terraform, maybe, but mostly going to be using Amazon. They're going to be interacting with Amazon Web Services. Developers don't really, today with Kubernetes, they don't really have any need to interact with Amazon Web Services because they can achieve everything that they need to achieve within Kubernetes. This is quite a nice model because it means that all of the complexity of your application, which is all the difficult stuff, basically sits in Kubernetes, where it's very easy to manage complexity. Managing complexity in Amazon Web Services is a nightmare. Managing complexity in Kubernetes is a dream. It's the latest, well, it's now quite old, but it's still, the latest generation of a hosting platform. It's the latest generation of application management platform. AWS, a little bit crusty nowadays, and you need a lot of time and quite a lot of resources to build things here, unless you put all of your complexity in Kubernetes. So the platform team is responsible for deploying Kubernetes. They're responsible for deploying database instances. The software development team is responsible for consuming those services. Developers are responsible for schema. Your application in Kubernetes has a schema. Your application in a database has a schema. The development team should be fully responsible for CI/CD. Perhaps the platform team provides support. Perhaps they're making sure that there's maybe they're keeping an eye on security, something like that. But really, the development team have to own the life cycle of that application. If you build it, you run it. So Amazon Web Services, I'm going to talk about cloud providers now a little bit. So Amazon Web Services is a first generation cloud technology, and it's quite badly done if we look at it critically. The different services are not very well integrated. Amazon Web Services doesn't provide us with a bunch of easy defaults. The learning curve with Amazon Web Services is brutal. I specialize in upskilling teams with Amazon Web Services, and it's hard to do. Amazon, I don't know whether this is intentional or not, but Amazon Web Services basically promote DevOps engineering as a kind of a culture because it suits their engineering paradigm. I don't know whether that's intentional or not. It's similar to the way that, for example, SAP is working. So SAP, a popular provider of ERP systems it's a global provider of ERP systems, been going for a long time. You cannot use SAP without SAP consultants. And in the same way, you can't really use Amazon Web Services without DevOps engineers. So they kind of promote DevOps engineering as the access method to their platform. In my opinion, Google Cloud is much easier to learn. So if we go back a couple of slides, with Google Cloud, you don't really need a platform team. You basically need a dev team that can take over the platform team role, because it's much easier to consume Google, because it just works out of the box with very, very easy defaults. This Google Cloud Platform was what was selected by the case study customer as well. And a lot of, I have customers, we have customers. We have customers that use both Amazon Web Services and Google Cloud. It's about 50-50, but I always prefer to do Google Cloud because it's always much more fluid. It's a much easier push from an educational perspective. Azure, yeah, I try and stay away from Azure. Let's put it like that. There are problems. Let's leave it there. So basically, we managed to get, using these principles that we just talked about, we managed to get DSMI out of the mud. And in fact, we sold them a specific product, which I'll talk about very shortly. So basically, I'll just let you read this. So we managed to get them up and running. They're already using Kubernetes, but we gave them the right pattern. We gave them proper CI/CD process. We gave them review apps, the ability to independently deploy branches in Kubernetes. A deployment to Kubernetes became part of the standard test of their application. So if a deployment was broken, you could not merge that branch into master, for example. So we gave them this type of power, and that happened very, very quickly. So now it's time for the plug a little bit. So hopefully this explains how we're working. So as we said before, we're purely focused. Darwinist is purely focused about delivering educational outcomes. So the way that we consult is by delivering educational outcomes. We teach people on the job. That's the only way that it really works. You can't really take people away from their work and teach them anything useful. This allows us to avoid any kind of unhealthy dependency on us as well. We don't want you to be dependent on us because it's annoying and difficult. And we are very, very focused about helping our customers invest directly in their staff. We want our customers to focus on the continuing professional development of their technical staff. It's something that's extremely difficult to do, but that's what we specialize in, is making sure that that happens. This does wonderful things for reducing staff churn, for example. Any developer will tell you that if they really want to get involved with the new technology, if they want to learn a new technology, they generally have to switch jobs. And we're trying to break that cycle. So our main product is a skill sprint. This is for when a business is very focused about what they want and they want it quickly. So the business says, we want Kubernetes. And basically, we turn up, take 3 of their developers, make it happen, and leave them in a sustainable position. We don't touch a keyboard. Everything is delivered by the customer's staff. And this proves that this capability has been properly assimilated by that team. They're able to then develop things further. They're able to then reorganize and redo things how they want to do them. It's not about delivering a blob of mess in the middle of their infrastructure. It's about giving them the tools and the experience to be able to move things forward. For example, DMSI are already doing a bunch of stuff that they've taken our work that we did in that week, and they've taken it a very, very long way away from where they started. Our other product is capability cultivation. This is a much slower sort of time release. This is generally happening over the space of a year. This is when an organization is a little bit unsure about what they want to do. Well, we know that we need to move to the cloud, but we're a little bit unsure about what that journey is going to look like. We need to learn more slowly. We're a little bit unsure what our goal is. We have a mission, but not necessarily a clear objective. But again, the output is always delivered by the customer's employees, because it's really about, again, building capability inside these organizations. That's what the most important thing is. These are generally the technologies that we work with. I mean, it's the usual. I should really take away the Azure one here, but it's really the usual set. Google Cloud we do a lot with. Amazon Web Services we do a lot with. Git, Kubernetes, a lot of Python. I'm a Python developer. I tried to learn Go, but yeah. And of course, PostgreSQL, MySQL, obviously DevOps down here. So use cases. So we work with any company that wants to use an external company when getting to grips with new technologies. We also work with technology vendors that are struggling with customer success. So, for example, if they're struggling to help a customer to really get to grips, if they're struggling with their customers, if they're struggling with the journey of their customers, if their customers are not really getting properly emotionally invested in their product, this is something that we help with. But this is something that you can do as well. So if you're building a product, think about what is the educational journey that my customer needs to take in order to be successful with my product. It's a really, really good question to constantly keep at the back of your mind. How is my customer going to learn this? Because if your technology is difficult to learn, you're going to have a bad time. Thanks very much. That was a little shorter than I was imagining. But yeah, any questions?
Hello, Andrew. Welcome back on live stage. Thank you so much for this very interesting talk. So, I hope you're ready for some questions.
I am.
You are. All right. So then maybe also to you, Andrew, how did your tech career start in the first place?
I was pretty much taken off the street by a supercomputing company based in the Netherlands. Yeah, I'd done a little bit of coding, and they put me to work designing supercomputers, which was a weird leap. But yeah, that's how I started. I moved to Germany because I was working on various large-scale compute projects over here, and then I slipped into the commercial. I moved to Berlin and then slipped into the commercial sector, basically. But for the past 4 or 5 years, I've been focused on the educational side of things.
Okay. So thanks for that answer. Do you also remember the first computer or machine that you've worked on?
You mean the first supercomputer or the first computer?
Both.
There's been a few. One of the most interesting things that I worked on was for a large project at the University of Bristol, for example. The first computer that I didn't really get into computing until I was probably in my, early 20s. I'd had some exposure, but I didn't really start getting really into it until maybe in my early 20s. I was a little bit into it in school, but not so much. But really, when it started getting heavy, when it started getting serious, was when I was doing I had to learn very, very fast when I got into that industry. It was a baptism of fire. All right.
Thanks for that answer, Andrew. We just got a question from Larson, who wants to know, great talk, Andrew, thank you. What is the most complicated assignment you have done?
So we've been working with a company so there's a case study on the website, so I can talk about this. We were working with a company in Bosnia and Herzegovina, and they were working with a very, very weird, crusty PHP stack. It's a quite famous one in Germany, so I'm not gonna mention it. But it was very, very crusty, and they were using a very, very small part of it for their application. And they basically needed to retool their entire. They needed to retool their entire team. Basically, they needed to get away from PHP. They needed to get to grips with Kubernetes. Their Elasticsearch was completely owned by the CEO as well. So the only person who understood their Elasticsearch implementation was the CEO. And so we basically provided them with a series of three. Skill sprints, basically. The first one was with Kubernetes and helped them to basically get control of this big, scary monolith so that they could start to pull it out. So the most difficult bit was let's get control of the big PHP monster so that they could start to pull it out into microservices. But you need to do that, you need to have really advanced CI/CD. You need to have really advanced deployment. So Kubernetes and CI/CD was a really, really important part of that. Once that was up and running, a month or so later, we did Elasticsearch, and we completely refactored their use of Elasticsearch. Well, we didn't, they did, but we provided the pattern for them to be able to completely refactor their use of Elasticsearch. But that was also then in Golang, because they wanted to also get away from PHP. They had some serious concurrency problems that they needed to solve. And then the final one, which wasn't delivered by me, that was delivered by two people from North Macedonia. So two Golang developers from North Macedonia went over and then delivered an intense session to basically convert 4 of their PHP developers into Golang developers. And it worked. The company was then able to then professionally develop Golang microservices on a really, really advanced level. And it was a tricky journey, especially with the Elasticsearch stuff. That's pretty tough. Finding the right pattern for Elasticsearch is really, really hard, like really hard. It's a weird one, and also reskilling PHP developers into Golang is also quite tricky as well. But it really, really worked out. Yeah. So that's yeah.
Okay, thank you for that. Talking about assignments and your work in general as CEO, what does a normal workday looks like, if there is something like a normal day?
Yeah, so it's we just set up. So the business was set up last August, and we have been. Yeah, the business was set up last August, and we've been basically putting together the business, trying to work out how do we market this stuff. We're doing things quite differently, and so. But how do you explain people? People are like, oh no, you're doing training. It's like, no, we're not doing training. Oh, you're consultants. Well, kind of, but not really. And it's very, very difficult to be able to explain to people quickly and efficiently, like, what are we doing? And that's been a challenge. Is to a lot. The customers that we get generally get it straight away. They're like, oh yes, I've got an immediate problem that can solve it. Yes, we're ready to roll. We do want to invest in our staff. We find a lot of companies, they're not really interested in investing in their staff. Like they don't get it. They don't understand why that's a good thing to do. And that's weird when you approach when you find those companies. They don't really see our customers. They see the correlation between a good quality product and a good quality staff member, right? They know that the only way that you can get out a good quality product is by having a good quality staff member. And they know that by improving the standard of their staff, by upskilling their staff, by investing in their staff, they're going to get better work, right? They're going to get a better product. They're going to have happier customers. They're going to make more money. It's how it works. But when you get more corporate, that relationship between producer and product becomes really, really blurry, and less. But some large corporates are very, very focused on it as well. So it really depends on the attitude. But that's something that we're trying to work out, is how to identify customers, how to identify managers that really want to make the investment, that really want to upskill their developers, that really want to help their developers to do new things quickly. Yeah, that's the major challenge that we're facing, actually. And generally the sales is a brutal world. It's not something that I'm an engineer. I'm not prepared for the sales world at all. Yeah, doing these conferences is also quite challenging, but quite enjoyable as well.
You did really well, if I might say.
Well, thank you very much. Yeah, no, I apologize, and I want to say, like, I wanted to avoid it being like just like a sales pitch. The point that I'm trying to make, is that the point that I'm really trying to make, or I wanted to get across, the narrative that I want to give, is that software developers or engineers, they do not receive investment on their jobs. It's not something that happens, right? Because it's almost impossible to do. It's very, very difficult. So training is very, very difficult to get in. It's very, very difficult to get a proper return on training. Consultants, this is basically taking away ownership from developers. And developers are basically developers move jobs every couple of years because this is the only way that they get new skills, they get new challenges. Maybe if you're working for a big company, you can move between teams to do new things, maybe. But if you're working for a medium-sized company, maybe there's only one development team. You know that the stack that you're working with is getting weird and old and crusty, and you're like, well, I can't change that. I can't ask my organization to change, because it's also nearly impossible to change stack as well. That's also very, very difficult. But there are ways of solving this. There really, really are ways. The methods that I'm talking about, this is stuff that you can also do. I'm hoping that you can take bits and pieces of what I'm saying and going, oh, okay, well, that's a difficult thing to do. Let's rethink about how we're going to do that. Let's rethink about how we're going to try and introduce new technologies. Let's rethink about how we're going to work with our junior developers, for example. How does the relationship, what I find a lot, that the relationship between senior developers and junior developers, there's not much knowledge transfer happening there often. And so I speak with a lot of junior developers, for example, that are very, very frustrated because they're not receiving investment. They need guidance, but they're not getting it. And this has been exacerbated because of COVID. People are working away from the office. This has really made the situation a lot more difficult for juniors. We also need to think about, diversity. We need to think a lot about diversity. I speak to a lot of young female developers that honestly are in a quite hostile environment, and these are things that we need to think about as well. But they're difficult problems to solve. It requires awareness and thinking of a level that a lot of engineers like myself, we struggle with. So there's a lot of really, really interesting challenges. But if you can work out, or if you're responsible for a development team, or if you're in a development team, try and think about, what are my educational goals? How do I get to those educational goals? Can I design those educational goals? What educational goals are going to deliver value to my organization? If as a developer, you can design an educational goal, then becomes much easier to sell that to your organization. You can basically design an educational goal and say, dear boss, this is the goal I want to achieve, and here's the route that I've designed. It can be quite basic. Here's the route I've designed to get us to this point. It's much easier to get sign-off and time and space to be able to do that upskilling, to be able to, so maybe if your organization's not investing in you, you can pull the investment out of your organization. It's a tricky thing. It's a really, really tricky thing. And yeah, there's a lot of attitudes that need to change as well. So it's a long road for that.
Yeah, but we are working on it, and you're helping us. So, Andrew, thank you for that elaboration as well. I have another question from Alexandra. She says, really enjoyed your talk as well. Thanks, Andrew. How do you approach working with a new team? Do you start with a skill sprint on their real project they're working on immediately? Exactly.
So that's a really brilliant question. Yeah. So kickstarting stuff off is a really challenging thing to do. And this is, you have a blank slate essentially, and you have a lot of teams when you're starting a new project, when you're getting a new project going. You basically have about 3 months. You have this what's it called, forming, this process where teams come together. And this is basically people saying, well, I want to use this technology, I want to use this technology, I want to do it like this, I want to do it like that, and so on and so forth. And that process normally takes about 3 months to 6 months to really resolve. Normally, with a new development team, it's going to take you at least 9 months before you start seeing real productivity, generally, if it's not guided. If it's guided, you can generally get teams through that period very, very quickly, as long as you have proper guidance. If you have somebody who really understands, what the end state's going to look like, if you do have a senior developer that's able to sort of vision what that end state's and is able to provide, you can't completely squash all discussion. That's not appropriate, but you can provide guidelines. You can say, okay, well, you can provide a more, sorry, I'm trying to divide this. You can provide a narrow set of guidelines, and you can say, well, let's try and keep within here. So you can bounce around within these guidelines, but when somebody starts going off on a weird tangent, then you need to bring that back in. So the really good senior engineers know when things have gone off on a weird tangent rabbit hole. So if you have a really good senior engineer around who's able to guide things back, you can't squash things down to a single narrow line saying, no, this is the way it's going to happen and this is the way you're going to do it. That doesn't work. But if you can provide the guidelines. I do work with new teams on new projects, and so my job is basically to try and provide these, in these situations, my job is to try and provide these guidelines. And yeah, you can generally, if you can find somebody who can give those guidelines, you can generally cut that time to first value, the time to first productivity, you can probably cut that in about half. So you can probably start seeing real value. I'm talking about the first value, the time to first value is the first time that this effort delivers value to the organization. So if that's unguided, 9 months, maybe even a year in some cases, it can be really difficult getting a new team formed and productive. But if it's guided, that time can be much, much shorter. But yeah, finding those people that can do that effectively, they're few and far between. That's a difficult thing. If you have a good CTO, basically, if you have a good development director, if you have a good lead, that person should be able to squeeze that down.
Okay, thanks for that. Also, I see Alexandra also thanks for the answer, and she already has a follow-up question. Who suggests the new skills that are needed? The senior dev or the PM, for example?
That's a really good question as well. So that's a really, really good question. It really depends. I think it can come from anywhere. So, for example, the customer in the US, DMSI, they'd been like rattling around with. They knew that Kubernetes was what they wanted, and they'd just been rattling around with it for. They'd just been rattling around with it for a year or two. Interesting. Customer in the UK, they're a heavy user of Amazon Web Services, and but they knew that their consumption of Amazon Web Services was really weird and crusty, and it was actually the technical director, that was like, okay, we need to redo all of this, we need to refactor all of this. But I think it can come from anywhere. But the problem is really selling that. That's the thing. Even if the thing is if you're a junior developer, getting traction for new ideas within development teams can be really, really difficult because it's hard to do. People generally don't want to do it. It's a lot of work to refactor things, to introduce new technologies. You have to think a lot. So I think generally that's just going to be sort of coming from higher levels. But I think if you can get all of your ducks in a row, if you're a junior developer, I think if you can get all of your ducks in a row and you can make a case for it, and you can say, well, this is how we can get there. If you've got the ear of your CTO and you're like, hey CTO, what we're doing here is a little bit crusty and a little bit weird. Wouldn't it be great if? But then you have to be able to think about what's the journey to that new technology, to that new stack, to that new hosting provider, to that new database. So for example, if you want to start using Elasticsearch, for example, your search stuff is really weird and slow, and that Elasticsearch is a way of doing that. For example, how are you going to get there? How are you going to find that effective pattern for Elasticsearch? How is that technology adoption process going to happen? And it's very difficult often to be able to imagine how that's going to work. But you can always call me and I'll provide you some guidance.
But happy to hear that. So, another question from David. What more general question? What skills and trends in IT do you recommend to learn?
Kubernetes. I mean, Docker and Kubernetes is if you have, if you're already, if you're a reasonable level software developer or, junior software developer, this DevOps thing has to be owned by developers, and everybody knows it has to be owned by developers. Like, it's not, people don't argue with me on this. Well, rarely, sometimes, mostly don't argue with me on this point. If you're a developer, you have to own the life cycle of your application. If you build it, you run it. It's really, really important. You have to know CI/CD. You have to know Kubernetes. If you go back, maybe I can just quickly put this in the chat. But the link to the repository, maybe I should quickly find that and post that. Maybe we can pop that in the. Wait 1 second. Let me just find it. If you can get your head around this, and GitHub Actions, for example, is a really, really important thing that you need to know. If you can't deploy your code, so whereabouts do I post this? Do I just post this in the comments chat here, or?
You can do this. Maybe you can send it to Gary, and he will post it.
Okay, so I'll just put this in there, and hopefully that'll get posted.
Perfect.
So get your head around. So if you're a developer, you need to get your head around Kubernetes. You need to get your head around Docker. You need to get your head around CI/CD. You'll make a lot more money, and you'll be a lot more useful if you do. As a developer, as well, one of the biggest missing skills right now is really is also DBA skills, database administration skills. This is really, really missing a lot. So a lot of development teams are obviously going to be using ORMs, which is proper and good. But if you can really get your head around what the database is doing, you can then improve the performance of your application a lot. If you can really, really dig down to what's happening on the query level, if you can work out how to optimize queries. ORMs are great for the early stage of development, but if you're doing something high volume, or if you're doing something latency sensitive, you're going to need to start digging into the database and understanding how to improve the performance of that database. And that's always going to happen on the index level and on the SQL level. And so if you can really get your head around those topics, you're going to be much more useful to your team when those types of problems come up. Also, Golang. Learn Golang. I think the two languages which I think are hottest right now are Python and Golang. Python is great when you need to churn features. Golang is great when you need performance. And I think these are the two most important things. Obviously, there's JavaScript as well for the front end stuff, but for back end technologies, Python and Golang are really, really the go-tos today. They have the most mature library support as well. Yeah, so if you need to do things quickly, Python. If you need to do things concurrently, then Golang is really important.
Okay, thanks for that answer also. We have another question from Henry. What do you think will succeed Kubernetes in the future?
That's a really good question. Yeah, that's a really, really interesting. I mean, Kubernetes is just an orchestration engine, right? So all it is, so basically we have Docker, and Docker allows us to basically turn our application. I mean, Docker is basically a virtual machine when you really boil down to it. It's a virtual machine. You can slap it on a computer, press a button, and it runs. Okay, it's a bit different, but it's what we call it's what we call kernel level virtualization, I think, as opposed to full. I can't even remember the types of virtualization. It's a long time ago. Anyway, so Docker is a virtualization technique. So all Kubernetes is doing is orchestrating a number of virtual machines. It's just saying, oh, well, the user has asked me to make sure that 3 of this virtual machine should exist and 4 of this should exist, and that this topology should exist. That's all it really does. I'm not that convinced that it does that particularly well. It's better than anything else that we have, but it's still a bit clunky in some areas. So I imagine that I think what has to come first is a new containerization. We need a new, because Docker is also a disaster. So it's not the most well built of it's not the most well designed or well built of tools, but it's what we have. I mean, Linux itself is a disaster as well. Let's just say all IT is a disaster. So I think we need to find ourselves a new containerization technology first, and there's a few, and I think that's going to take about 10 years before we start seeing a good new containerization technique that's easier to use, a new paradigm for containerization. And then off the back of that, what we'll probably see is then a new orchestration engine. I still think we'll be using containers and orchestration engines for deploying our applications. But on my radar right now, there's nothing that I think, I don't think there's anything that's gonna supplant Kubernetes. I mean, Kubernetes is basically just one king of the orchestration engines. It beat down Docker Swarm. It beat down, I can't even remember what it was called. There was another one that was around that I can't even remember the name of. So but Kubernetes has basically won that battle. Kubernetes as well came out of Google. I don't know if everybody knows that. It's basically kind of like a copy of their internal infrastructure. But in terms of what comes next, we'll have to see a new containerization technology first.
Okay, thanks for that answer also, Andrew. And so are there any further resources you might want to share with us, like books, YouTubers, blogs, something like that?
I should have that, but I don't. No, I don't. But I would really, really suggest, in fact, there's a course on Coursera, which is learn about learning design, learn about instructional design, because this is the biggest weakness in tech at the moment. We don't know how to teach. We don't know how to transfer knowledge to other people effectively. We don't know how to think about knowledge. So if you can find resources about instructional design, and there's courses on Coursera, for example, that are pretty okay about the basics. If you can start to think, what's my learning journey? What are the learning outcomes I need to see? What are the learning outcomes of my colleagues? What's the learning outcome of my boss? Then you can start to think a little bit differently. The only way that we're going to get diversity into tech is by delivering effective learning outcomes. At the moment, everybody's a bit like, no, these are my toys, keep away from my toy. This is my stuff. It's not a great attitude, really. And so if we want to break that up, if we want to have a more inclusive and a more fun workspace, we need to get our head around how people teach and learn technology. It's hard to do, and it's ignored across the board. Nobody does it. Nobody even thinks about it. So that's what I'd suggest as a next resource.
Words to live and work by, I would say. So, Andrew, thank you so much for the amazing talk and the really nice Q&A. I hope you had as much fun as I did, and see you next time. Bye.
Thank you very much. Take care. Bye-bye.
So, and before we come to our last speaker of the day, we will have a short break of about 8 minutes. Stay tuned.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So welcome back everybody to the last speaker of today. He is a cloud transformation consultant at Luminis, an active software community member as well as the leader of the Dutch AWS group. He loves to share his knowledge by blogging, training and speaking at conferences such as ours today. Last but certainly not least, please welcome with me Piet van Dongen.
Hi, Benedict.
Hi, Piet. So happy to have you. How are you today?
Thank you. I'm very pleased to be here. I'm good. It's a bit rainy outside. Last week we had a spring sort of weather. Now we're back to winter. But apart from that, it's all good here. Thanks.
Do you mind me asking where exactly it's rainy?
Yeah, I'm in Arnhem in the Netherlands, near the German border.
Beautiful. So, Piet, what are we going to learn from you today?
Yeah, so we did a sort of serious gaming thing to become more cloud proficient at our company. And I thought it was a really fun process to endure. And I wanted to tell you all about it today.
Piet, sounds fun. So ready when you are, and I would say the stage is yours.
Thank you. All right, let me switch to my notes. So thank you everyone for joining me today. I will be talking about the thing we did at our company to become more cloud proficient. So let me start with an outline first. And some nice animations. All right, so what I'm going to talk about today is very much a story of what we as a company at Luminis did to become cloud natives. But it's not just about our company. I think it is very applicable to any organization that has embraced software as a driver for innovation, which should be a huge portion, if not the vast majority of companies these days. So I will tell you what we did, and I will try to substantiate everything so you can use your experience to kickstart your own cloud native transformation. So the first part of the talk will be about why would you want to become cloud proficient? And once we have the hang of that, I will tell you how or what cloud proficiency actually is and how we did that, how we became more cloud proficient, and you can do too. And the best news is that I have some nice demos included. So I will show you what we did, including some applications we built on AWS. Okay, but first my favorite slide about me. So I've told you my name already. This is me in Las Vegas at the AWS reInvent Summit this year. I'm a cloud consultant at Luminis. That's the company I work for, which means that I spend most of my time helping organizations drive innovation using cloud technology. So I help IT become a function of the business. So I advise companies, I help them implement stuff, or a combination of both, together with my colleagues. I'm based in the Netherlands, in Arnhem, near the German border. And I'm also active in the community, especially in the AWS community. I'm one of the AWS community builders. And I'm also one of the leaders of the Dutch AWS user group, which means that we have regular meetups where we talk about what we did using cloud technology and share knowledge there. And I'm active on Twitter, which I really like as a platform because it's easy to connect with like-minded people and share knowledge there as well. So I'd like to welcome you to my Twitter account. Right, so that's about me. Now, the thing our company did is we had a fairly simple goal. See, our strategy is to drive innovation for our clients with data-driven and cloud-enabled solutions. And what we wanted to do was become more cloud proficient,
Piet?
So we could help. Yes.
Piet, so sorry to interrupt you, but there seems
problem.
to be a problem with your slides. Oh, it's gone now. Okay. I think now it's working properly.
Yeah.
Sorry for the
Can you see them
interruption.
well?
Yeah,
No
now it's
problem.
perfect.
Okay.
Sorry
I'll
for the
pick it up from
interruption.
where I
Please
left
go
off.
on.
No problem. So, and let me know if there's something wrong again. So, what I wanted to do internally was start a journey, so to speak, where people could become cloud proficient in a positive, self-managed way, and go from a starting point to a point on the horizon and never end becoming more cloud proficient. And we wanted to start as soon as possible, because as you can see in this journey, once you start a journey, you're actually learning where you will lead to. So the other thing we had as a goal was to attract new clients and maybe new colleagues. And what we also wanted to be is become a better partner for our partners, AWS and Azure and Google. But before I head into the details of cloud proficiency, I wanted to quickly remind everyone of what I mean when I say the cloud. So we all know this funny sticker, there's no cloud, it's just another computer at the other end of the internet, but that's not what I mean when I say the cloud. So what I normally use is the definition as created by the National Institute of Standards and Technology in the US. And it has 5 pillars. The first one is that the cloud is all about on-demand self-service. So employees can provision resources themselves without any interaction with other humans, which saves them time they can use for their creativity. Another one is broad network access. So the platform, the cloud, should be accessible by phone, desktop, tablet, workstation, from home, but also from Starbucks or from the train. Resource pooling is an important property of the cloud. So you don't have to think about physical details like servers and network cables. And cost should be predictable and low. It should be elastic, so it should automatically scale up and down with virtually no ceiling. And the last bit, that it should be measured. So your usage should always be visible, and cost control should be almost automatic. So if I'm talking about the cloud, the next 30 minutes, I mean this definition of the cloud. Okay, now let's start off with the why. Okay, so the customer, so your customer or your client's end user, has a dream, and they are looking to realize that dream. So you are selling something, but what they are buying is something else. So if you're selling skateboards, for example, you're not just selling plywood and some wheels and some nuts and some bolts. You're actually selling a better life for that customer. So maybe they want to become a really cool kid at the skate park, or they want to impress their friends, or they just want to become more fit. So the thing you are selling is a different way or a better way of life for your end user. And to get them to that end goal, you have to innovate, because users don't normally know exactly what they want. They have an idea. But the thing about innovation is that it's a journey that you work through together. So each innovation creates a new normal, so to say, for your customer. And what is special today is normal tomorrow. And that creates the need to keep innovating. So to work each day on a better tomorrow. So that means that you have to make new things, like products or services, but you also have to improve existing things. And the faster and more flexible you are, the greater the chance that you are the first to create something new or improve something. And if you're too slow, someone else will be first. If you're not flexible enough, someone else will outmaneuver you. So if you're nimble or agile, but make the wrong thing, you're not innovating. So thinking is not enough. You have to act, and you have to act quickly and nimbly. So you have to experiment. You have to build something. You have to measure what it does. You have to learn from it, and then you have to build or rebuild again. Learn from that, measure stuff, etc. So you have to get this flywheel of creativity going and get better and faster at it every day. Now, like Edison said, the light bulb he invented was not the first iteration of his idea. He failed 9,999 times, and the 10,000th try, he created the light bulb as we saw then, and it has been iterated on today. I have no regular light bulbs in my house. I have LED ones. So like he said, you have to keep failing or experimenting to find something that works. So you have to start that flywheel of innovation, and then you will discover together with your customer what their job to be done or their dream is and how you can improve their lives. If something fails, you want to discard it quickly and painlessly, which is also known as failing fast. And the focus has to be on nimbleness or agility. So a short time to value and maximum flexibility. So let's have a closer look at organizations that are masters of innovation. So these are some facts straight from the Accelerate State of DevOps report. And they have discovered or grouped together some organizations and grouped them into performers leagues. So you have the low performers, the ones at the back that are really slow at adapting technology and innovating. You have some medium and high performers, and then you have elite performers. And I want to compare these low performers and these elite performers, the leading group. So the first thing they've measured is how long can these organizations put ideas into production. Well, for the elite, it's less than a day. So if the elite group of organizations that use technology to innovate have an idea and they want to put it into production, it takes them less than a day to build that change and deploy it. Whereas the low performers, the back of the field, take 1 to 6 months to deploy their ideas into production. So you have 1 or 2 releases, 2 to 12 releases a year. And when the time for release comes, the elite can do it immediately with just a press of the button, where the low performers take longer. So they batch up the changes and do releases to the clients, so into production once or twice a year. If we look at running performance, then the elite introduces much less errors and can recover from failure really quickly. So if there's something wrong in their services or products, they can fix it within the hour, where the low performers take weeks. And to make things worse or better, depending on which group you're in, the elite introduces almost no errors into production, where the low performers do half the time. So if you stand back and look at this field and imagine what these groups look like, then you get a picture of a race where there are some people in the absolute back that are struggling to keep up, and you have a heading group of a few organizations that are really good at leveraging technology, especially cloud technology, to get what their customers want, to innovate. And the fun thing is that, or it's not a fun fact, but the fact is that the elite performers are 24 times as likely to use cloud technology compared to the rear guard. And the good news here is that the cloud, as I was defining it before, is available to anyone. So all those hundreds of managed services in Azure or AWS or Google Cloud are waiting to be used. And the entry fee is extremely low. Anyone with a credit card can start building today. And if you do it well, you only pay for what you use. So that means that experimentation has become super cheap. If your experiment fails, you just turn it off and you stop paying for it. And you only pay if your customers are actually using what you made. So the cloud scales with your success. You don't have to invest in tons of hardware and maintenance. You can just take that money that you put in and put it into pure innovation now. So that's what the cloud has to offer. And that is, in my opinion, why anyone that's serious about software development should consider the cloud seriously. Okay, on to the next section. What is cloud proficiency? Okay, let's tell you something about our company. So the company I work for, Luminis, is not one big company with a single office somewhere in the Netherlands. We are a sort of collective of locally oriented companies, each independently responsible for their results. So we are spread out over the Netherlands, and that works really well for us, since this reduces a lot of overhead, but mostly it increases the speed and local correctness of our decisions. So we have virtually no management pyramid, which means that each colleague has a lot of responsibility and control. And when people have to connect over company boundaries, for example, a project team for a larger client or a focus group temporarily organizing, they know how to find each other. We make sure of that. Okay, so let's focus on one of these cells, in this case, Rotterdam. So like I said, we have very little overhead. Almost everyone spends most, if not all of their time on adding value for clients. So we are very engineering heavy, being a software focused organization, but we want to be able to fully help our clients innovate. So we have project managers, some consultants, designers, front and back end engineers, and so forth. And we believe that to be able to innovate with our clients, everyone in our organization needs to be cloud native, or as we call it here, cloud proficient. So everyone, including these sales people, office managers, other managers, consultants, need to be able to understand and be able to explain what the advantages of cloud are, and they need to be able to leverage them, like I explained a few minutes ago. So what we did is we said, everyone that talks to our clients has to become cloud proficient. And that's not easy, but it's the assignment we put forth. So what we did first was created a categorization of cloud knowledge. So we have some people, let's call this blood types. So we have backenders, front-enders, designers, data scientists, and so forth. And these are generally the types of positions or roles we have. I think it's very transferable to other companies. And we have some knowledge groups or themes. We have basic cloud knowledge, for example, compute, data, operations, and business knowledge. All themes, but all cloud-related themes. And you could divide these into subgroups if you'd like AWS or Azure or Cloud Fundamentals, etc. So now we have a matrix. And for example, the basic stuff, a backender has to know the basic stuff, of course. Compute, yeah, sure. A backender has to know about compute, like virtual machines, containers, data, databases, maybe also machine learning, operations, how to manage cloud environments and platforms. And the last example, maybe this backender doesn't need to know much about what we do from a business perspective, like cloud economics and consultancy. So now we can quantify the needs for the different roles we have. So the backender has a certain profile, and a front-ender has a different profile, as does a salesperson, a designer, a consultant, and a data scientist. So as you can see here, we have fully capable teams if you put them together, but they have a certain view on cloud technology, and they have to have some knowledge in a certain area. Everyone has to have basic knowledge, and there are focus areas depending on the role. But altogether, we should have a cloud proficient organization. Now, before we dive into the how, one more thing about knowledge, and I think the previous speaker also mentioned something similar. So our company, we are not academics, and even in the academic world, knowledge is useless without skills. So what we aim for is not just the development of knowledge. We want all our colleagues to become proficient. So that means that they can put their knowledge into practice. So if knowledge looks like this, a group of stuff you know, then experience is knowledge put into practice. So you connect the dots of your knowledge by practicing it and seeing how they are related, and it makes it stick much more easily than just some groups of stuff you know about. So knowledge is experience is knowledge put into practice, and there's another advantage in aiming for experience and knowledge. That is that not everyone has the same learning strategy. So me, for example, I'm a top-down learner. I want to experiment first, which gives me some knowledge and some experience, and then afterwards I read a book or some documentation, and then I start practicing again. So I go back and forth between gaining knowledge and experience little by little, and then creating this whole network of experience. And some people are bottom-up learners. They want to gain a lot of knowledge first, and then just practice it. So to solidify the experience, everyone has a different path. So some read a book, do a course first, then put it into practice. Some people do it the other way around. We have colleagues that are really good at getting cloud certificates, for example, and we have colleagues that have no certificates but are really good at cloud stuff, and vice versa. So what we aimed for was try to help as much learning types as possible with this program. So how did we do it for our company? So once again, we are a networked organization, so we are locally optimized. And that's nice and speedy and agile, but it complicates things somewhat if you want to move somewhere collectively. So as you can see here, knowledge or working together between these cells, it doesn't go very fast. It's not optimal. So how do you get people as a whole company, in a network company, to move in the direction you have set as an organization, especially such a distributed one? And this pandemic certainly helped almost every organization accelerate towards a similar model with all people working from home. So it turns out you can actually do a lot of things, and it really depends on the type of company you are, the resources you have, the power structure, etc. What we did after considering things like learning paths, guided training course, full curricula, we settled on motivating our people. So that is, we don't tell people what to do, but we guide them in a certain direction. So that's what we think fits our organization best, and we believe this gave us the greatest chance of succeeding in this transformation. So if we look at motivation as a driver for learning, motivational theory tells us it has 3 pillars. So the first one is direction. That's also known as the goal. So what is the thing we should learn and what is it not? So you need to have a sense of direction, because otherwise you don't know how much you have covered or if you're actually learning anything at all. So everyone can set their personal goals, but we can define a baseline, sure. Then the second pillar is intensity. So this is basically the speed at which you learn. Highly motivated people with deadlines tend to be intensely motivated. Some not so much, for example, when they have low intrinsic drive to learn. So there's a difference. And the last pillar is persistence. So the amount of time someone keeps at it, keeps learning. And as we all know, motivation can drop off over time. So it's not a constant. But on the other hand, you can give people a motivational push, for example, by setting milestones or doing learning intervals. So together, these pillars form motivation. Now let's look at what we did to motivate our people, and you can too. So what we did is develop a program called Cloud Proficiency, which goal states we want 100% of our employees to become cloud proficient, like I explained in the beginning. And part of that program was the development of 2 web applications to support the learning. And together, these applications should cover all pillars of motivation. The first application we produced was the Cloud Proficiency app. And that's a collection of knowledge and pointers, which enables people to get a sense of what they should do to become cloud proficient, depending on their profile. So if you're a backender, you have a different profile than a data scientist, like I explained before. Then for intensity, the speed at which you learn, and persistence, the amount of time someone keeps learning, is covered by Cloud the Game. So what we did was we tried to activate people's intrinsic motivation using a serious game format. So we also do some extrinsic motivation here, but we do this by awarding people and groups that put in the effort. And since persistence can drop off over time, we motivate people in waves, for example, by creating temporary competitions and doing so-called game shows. Let's take a quick look at the architecture of the apps, and then I will show you a demo of the app as it is. So for the Cloud Proficiency app that gave structure to the learning, the architecture was relatively simple. It's a client, which you see on the left, that you get through a Amazon S3 bucket. And you have to identify yourself using Cognito, which is coupled to our company's Azure AD, Active Directory. So once you're authorized and you have the application loaded in your browser, we get the resources through Amazon API Gateway. And if there's a theme to be loaded or a user or you name it, the logic goes to an AWS Lambda. The request enters an AWS Lambda, which gathers the data for this person that is logged in and gives it back to the client, which parses it and displays it in an application. So it's a really simple architecture. We built this in literally a few hours, maybe 2 days, the first version. And then we just released it into the company. Remember, we wanted to start ASAP. And then people gave us some feedback and we iterated on it. So like I said before, we eat our own dog food. We want to innovate using feedback from the client. So let's have a look at this Cloud Proficiency app. So it's just a website which I can log into. It identifies me as Piet using my Azure Active Directory profile. And here I see some themes. So here is the theme first step. And I'll translate it for you live, it's in Dutch. And one of the pillars we have in this theme is a cloud fundamental pillar. So you can click on that, and then you have several tabs that will help you get a sense of what we mean with cloud fundamentals. So for example, here are some concepts, but there are also some sources like this video, which you can watch. So imagine you're someone that's totally new to the cloud, just entered our company, is not used to using a cloud service. You can go to this website, look at these sources, and just start learning immediately. Let's say you're a more advanced user and you want to learn more about serverless. Then you can go to the compute theme and click on serverless. And here, the same structure, you have some concepts. So you can look at a website that says what is serverless. In this case, it's Wikipedia. Or maybe you want to know about event-driven architectures. There are some services on AWS and Azure in this case, and some sources. And I, as an admin, can edit this and add new sources because the field is moving really fast. So here you can see that there's some information for people that just started their journey, but also some information for more advanced users, like this Lambda under the hood talk that you can click. So we have all these teams, data, SysOps, business, and this gives you that sense of direction we wanted to provide people so that they can start their journey. They have an idea of what we mean by the cloud, they have an idea of the level they are at, and they have some sources that they can dive into. All right. So now, let's dive into the other two pillars of the motivational framework. But first, show the architecture of the other app we built. So Cloud the Game, the other app we built, is all about the other pillars of motivation. And what we did was something similar. We built a client app that authorizes you using Cognito, also built with AWS Amplify, and also using Lambdas for the logic. The only difference is that the game uses a SQL backend, in this case, Amazon Aurora Serverless. And the reason we use SQL here and not DynamoDB or document store was that we wanted to be flexible, because we didn't know how people would interact with our application on forehand. So we want to be somewhat flexible in defining the usage patterns and optimizing around them. So let's do a demo of that as well. So that's also a web application. I can log in with my account. And once I do, I'm authorized and my data is retrieved from the backend. And as you can see here, I did one thing recently, but if you go back a year, then you see a sort of GitOps-like calendar here. And what you see here is that I've already done 204 cloud achievements and I gained 18 badges of 34. So let me show you quickly what I mean by achievements, badges. So here you can, it's a really simple app. You can do one thing only, or you can enter one thing only, and that's an achievement. For example, I'm now speaking to you at the WeAreDevelopers conference. So I have to get a URL here. And then I say the category is speaker, subcategory is I spoke at a conference, and the URL is wearedevelopers.com/live. I enter the achievement button, and as you can see, my achievement is entered, and I can add another one here. And sometimes I've entered something and I gain a new badge. And what we did here was not tell people how they could get badges. The idea was to motivate people by having them talk to each other. So if you, for example, go to my profile, you can see which badges I got. That's public information, but not how I got them. I can also go to my local company core and see what my colleagues did. For example, my colleague Hilmar, he had 101 cloud achievement. I know he is a more Azure-oriented guy, so he probably has different badges from me. He has an arts and crafts badge. I don't know what it is, so I can go to him. He's next door and ask him, "Hey, Hilmar, how did you get this badge?" So I can do something similar. So on the homepage, you can see what people entered recently and what is entered a lot. So you can also get some sense of direction here, but it's more about the impulse in motivation. One of the impulses we tried to do was through games. For example, the last few months of last year, we did the Cloud Olympics, where we did 9 weeks of team competition. So each company, each location was a team. And the idea was, for example, that they entered as much of a category of achievements as they could. And you could see live here which of the locations entered the most points. And at the end, there was a winner, a number 2 and a number 3. And at the end, well, our location won, which I'm very proud of, but it could have gone any other way. People are really inspired to do something here and work together really well. So at the end, our company won. At the beginning of the year, we did a more solo-oriented tournament where people were pitted against each other. So I was pitted against my colleague Jiang Kai, and I won the first round until I was pitted against Piet. He won my round, and he eventually lost to the guy that would become the winner eventually. And the fun thing here is that the winner is a UX designer, not a backender, which you might expect. And one of our directors also entered the semifinal. And what we saw here is that all blood types in our company were really motivated to achieve something and become more cloud proficient, which is exactly what we wanted to happen, what we weren't sure of until we did this. And the last thing I wanted to show is I can always look at the list of achievements I entered, so I can share them with my colleague. Okay, back to the presentation. So another thing we did was state of the game shows. So we put a camera in our office and started recording and broadcasting it to our colleagues. It was not too serious, as you can probably tell in a few seconds. But what we did was talk about what people entered as achievements, how our cloud proficiency journey was going. We put some people in the limelight and telling, whoa, this colleague has done something really special. She has, for example, spoken at a client and did a presentation on cloud, or maybe someone else created a really cool app. And we try to use this medium to, again, temporarily give an impulse to the motivation for our colleagues to become more cloud proficient. Okay, other boosters we had. We did some internal mailings. So we mailed people in a similar way as we did during the game shows, but with text. We did some lunch talks where we highlighted certain technologies or maybe some achievements people did, or maybe we wanted to tell about a project at a client that was cloud oriented. we had HR mentors, we call them internally, and their mentees sign agreements, or at least construct plans to become more cloud proficient, a way of motivating people. And we did a certification drive with AWS, where people, if they gained a certification, an AWS certification, AWS would send them swag. And the last thing we did was report, because we had some goals that we could quantify, and we would report on them if we could. So one of these reports I can show you is about app usage. So what we saw at the beginning, when we started in the beginning of January, that people were slow to start doing or entering this cloud proficiency game. Well, once we did that individual drive, that tournament, we saw that usage really picked up. And when we did the Olympics at the end of the year, again, we saw a pickup in the usage of the app, the number of achievements added. And if we look at the number of badges people gained and the amount of users that entered the game, you see that the tournament really helps give an impulse to this cloud proficiency journey, and thus to the motivation of people to become cloud proficient. Other results we saw is that we had a significant increase in cloud proficiency across the board. So technical and non-technical people put a tremendous effort in our cloud transformation. More concretely, the first 6 months of the program, more than 50 certifications were entered in the game alone. And a few weeks later, we got a badge from AWS that told people in the partner network that we as a company gained 50 certificates in a very short amount of time. But we also gained Azure and Google Cloud certificates, of course. So we got this distinction. One of the cool things, a personal highlight for me, was that our CFO became a certified cloud practitioner, which he also boasted about on LinkedIn. And that really gave an impulse to other people, or at least gave them the idea that this was serious business, because the CFO was involved. We saw a major shift towards more cloud-native projects and consultancy, which was exactly one of the goals. And we were able to attract new cloud-native talent. So a lot of new colleagues were already cloud natives. So they accelerated our journey to becoming even more cloud-native than we already had become. Another thing is that we were more visible in the cloud community. So I became an AWS community builder, as did some of my colleagues. And we spoke at certain cloud meetups and meetups like these. So overall, in our case, this last year we had a really good push towards a successful transformation towards cloud proficiency, which was the main goal of this journey. So, in conclusion, one of the major things we concluded was that motivating people is much more efficient than trying to enforce stuff. Enforcing people to learn helps or can work somewhat, but it's not, in our case, not very long lasting. So motivating people helps people go on a long lasting, never ending journey towards a goal, which you can also change based on what you've learned so far. What we did is not give people manuals. One of the reasons was that cloud is such a fast moving field. Another reason was that we want people to be self-sufficient. So we gave them structure, like with the Cloud Proficiency app, but we did not give them a learning path, a fixed learning path, or a manual, or a set of goals that they had to achieve. Another thing we did was we focused on so-called believers or champions at the beginning, and the rest followed suit. So at the beginning, we focused during these cloud game shows or people that were already self-motivated to make something of the cloud proficiency journey. And we saw that people gradually picked up what the other people did and had to become more cloud proficient themselves. One of the tenets of this whole journey was that agility and value, so speed and nimbleness, was more important than perfection or completeness. So like I said before, we created that cloud proficiency app, but also the game app in just a few hours with 3 or 4 colleagues. Just a pressure cooker. We released it, and we saw what people did with it, and that gave us another impulse, or the next enough knowledge to do the next iteration, and so on and so forth. So, like I said at the beginning, if you want to innovate, like we did here, you have to do it in small increments. If you look back, it's a huge change for us, but we did a lot of small steps and eventually accumulated into a big change. And one of the pillars of our journey was to have fun, as you saw in the game shows, but also the way the cloud, the game was designed. Fun was a big factor in this, because that's what work is also about, we think. So one of the things we said internally, if you want to go fast, that's easy. You just go alone. But we want to go far with our clients, together with our colleagues. So we want to go together. And that's why we did this at our company. And I hope that now you have enough information to, if you want to, start something similar yourself. You can contact me on Twitter if you want to know more. You can email me. I'll leave it in the chat. I would love to hear about your journeys, and I can answer questions now. Thank you.
Piet, welcome back on live stage. Thank you so much for this very interesting talk. Very interesting topic indeed. I actually, at university, I had a course regarding serious gaming, and I found it a very powerful tool, I must say. So thanks for that. And are you ready for some questions?
Yes, definitely.
Yes, perfect. So David wants to know, why don't you give employees free online courses like Udemy, Pluralsight, Coursera, etc.?
Yeah, that's a really good question. That's something we actually entertained, that thought. And one of the reasons we didn't want to do it is because then we would push people in a certain direction, and we would already start digging into the resources we had for the program. So what we decided upon was people could still get these courses, and we would sponsor them, but they had to figure out themselves if they would actually need them. So we did actually provide the resources to fund a course on a platform. But what we saw was that depending on the type of person, the way in which they learned, or the blood type they were, they tended to pick different resources. So it was certainly an option, but we wanted to tailor it to our colleagues, and we want to give people the message that they were supposed to self-steer their journey and not have a platform do it for them. That was an important one. But still, it's a really good question, and it's a valid option depending on the company you are.
Sounds reasonable. So another question, can you share the slides, please? I think that would be no problem. I think we can share it afterwards.
Yeah, let me restart it.
Yes, thanks. So another question maybe, how did your tech career start? How do you came to be in the business?
How I became cloud proficient, or how I started in this business?
Both.
Okay, and about the first question, did you mean that people want to see my slides, that I share them online somewhere?
Yeah, I think they want to have them on their own device too.
Yeah, so what I will do is I will create a Twitter thread in a few hours, and then at the end of the thread I'll put a link to the export of the slides.
Okay. Perfect.
So my cloud journey was a bit different. So I used to be a software developer, an engineer, mostly in the Java space, but also some front end and mobile application development. And one of our clients wanted to move their data center from on-premises to the cloud, to AWS. And the funny thing is that they had a really hard deadline, because their data center was supposed to be demolished in a year, and it was really expensive to replace it or to move to another data center. And they were already entertaining the the idea of moving to the cloud. So what I did there was mostly learn on the job. So I helped them migrate their stuff, and gradually I learned about the platform they landed on, the specifics of a cloud platform, and I did some development on there as well. So that's how my journey started. So I was motivated by a move to the cloud from a client, and a lot of learning in between. And once I did that, I thought with the colleagues that helped me, we should have everyone become cloud natives. So we started this program.
Okay, thanks for that answer, Piet. Maybe we jump forward a few years from your start. Now that you're a cloud transformers consultant, what does a normal day at your work look like? If there's something like normal?
Yeah, so the most important word in my title, so cloud transformation consultant, is the transformation part. So what I mostly do is try to help organizations leverage IT more effectively. So make IT a function of their business. So have technology help them towards their business goals. And what you see there is that change is not just technological, you also have to change an organization, the processes they have, the people, the products. So I tend to have a broad view, and I'm mostly involved with people that are change agents. So that's people from the so-called top of the company, the penthouse, to the boiler room, as Gregor Hope calls it. And I try to motivate them and let them see for themselves what the power of leveraging cloud technology is. So the first part of my talk was about why I think that cloud is a very a good platform, at least why you should embrace cloud to innovate. And that's what I explained. And depending on the people I talk to, I do it in either technical terms, if I speak to developers, or in architectural terms, or maybe in business terms. So most of my days, I'm mostly talking to people, trying to understand them, and try to nudge them in the correct direction.
Okay, sounds very interesting, Piet. I have another question. David wants to know what projects that you worked on so far are most interesting and difficult, or what were the most interesting and difficult?
Yeah, so the project I'm currently working on is the most interesting and also one of the most difficult ones I've worked on so far. I work for a client that used to or still has a desktop application, a Windows desktop, and they have worked on it for 30 years. So they have kept adding on feature after feature, and it's very central to their business. So they have to use this application to do their business. But they have also discovered that they can't stretch it any further. They can't vertically scale any longer. They can't virtualize stuff, and they need to escape from the single platform deployment they have. So what I'm doing now is try to discover what their business process looks like, and see how this application supports it, and from there work backwards to creating a platform in the cloud that will help them do the same thing they do now, but much more effectively. So that's not a journey that you can just draw out on a whiteboard, although I have certainly tried with my colleagues here. But it's something that you should have create a certain sense of where you want to go as a company, and create the first few steps in your journey. And then the hardest part is to convince people to just start building it. And that's really hard because, as you saw in one of my first slides, it's a journey. You can never, you could try to map it out from A to Z, but there are so many fundamental surprises, but also opportunities along the way, that you have to get in a state of mind that you have to start, gain a lot of flexibility, both business and technology-wise, and then go from there, learn something, and go from there again. So you have to get this flywheel of innovation going, and that's what this project is all about. And the hardest part for me is the people stuff. So technology is super interesting, and of course it's not easy to master, but actually making it a function of the business goals is really hard. Yeah, and also the most rewarding and most interesting part.
Okay, yeah. Sounds really challenging, but you sound very confident in it. So I think you will do just fine. So maybe apart from the ones you showed in your presentation, are there any further resources like books, YouTubers, blogs, something like that you want to share with the community? Yeah.
Yeah, I will also share them on Twitter. What I can say from the top of my head is what really helped us. What was I think David again said at the beginning. You have these great resources like Cloud Guru, Cloud Academy. One of the things helped me a great deal in my journey was a subreddit, AWS subreddit, for example. There's also an Azure one, where a community of people that are in the same boat, on the same journey, help each other get certified and learn about cloud technology. What I also do is go to meetups, conferences, go to conferences like this online one, where people that have a lot of experience and like to share it, tell about it. And one of the things I did last year, which finally I could do again, was fly to a conference at the other end of the world with a few colleagues, look at presentations, and then at night talk about them and really focus on what we wanted to learn as a group. That's what helps me most. But I'm a social learner, so depending on how you learn, there's lots of resources. I will tweet about it.
Okay, thank you so much, Piet, for the talk and also for the nice answers to the questions. I hope you had fun today. It certainly looked like you did. And I hope to meet you again someday. Goodbye.
Yes. Thank you for having me, Benedict. Have a nice day. Bye, everyone.
Thank you, you too. Bye. So, and now that we have heard 4 awesome speakers and are a lot smarter than we were before, there are just a few things I wanted to share with you. First, on April the 20th, we have our Security Day, a very special topic day as it is combined with a workshop. But as we have only limited participants for this, make sure to register for it on our website. And also, after the session, now is the time to go to worldcongress.dev to get further information about our World Congress in June in Berlin and to get some tickets. So, thank you all for joining today. I hope you had as much fun as I did and hope to see you next time. Bye.
Good morning,
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.